Good morning, everybody. Also from my side, good morning, everyone online. I hope you can see us. I hope you can hear us. If not, then shout. Welcome to DTCC and our Center Day 2026. This year with a focus on AI, as probably all events have now a focus on. So the title is Digital Twins in the Age of AI. And obviously, we have many new developments, new models coming out nearly every week, come with a lot of opportunities, but also a lot of challenges. So today, we're going to focus on that and hopefully answer some questions, have some very good discussions. You see the agenda here. We're going to have a mix of keynotes, of different discussion. It seems like we don't really have a super tight agenda, so there's the opportunity to ask many questions and to also mingle outside quite a bit. So I really already encourage you now to prepare your questions to our panelists, to us at DTCC management, and hopefully we're going to have a very good day. My name is Ben Ketzler. I'm the center coordinator, and I'm also back now from parental leave. So that feels also very good to be the moderator today and, well, basically start talking to you again. I know that it has been a bit more quiet the first year because we had obviously also a lot to do in terms of managing, in terms of setting things up, doing the transition from DTCC 1 to DTCC 2. But all that hasn't been so visible for the partners, really. So now it's time to really start with the projects, to start with concrete ways to engage for you as partners. And that day today is the kickoff for that. Yeah, a couple of housekeeping things before we get started. We're going to record this event, and then we're going to make it available also on our YouTube channel so that you know. And also for you online, feel free to ask questions. We'll try to facilitate that as good as we can here in the room. And that being said, let's kick things off with Anders, our director, and he will set the scene for us.
Great. So welcome everyone again to our first proper center day for DTCC 2. I will say something about what we've been up to for this past year and what we plan to do in the future. The main events today, as Ben said, that's listening to our keynote speakers and listening to our projects and talking together about digital twins. We have quite a sparse schedule in sense of having time for discussions and questions and so. And I look forward to the panel discussion later. So DTCC 2 is up and running. The first year has been to some extent about setting things up, even though that we had DTCC 1, things were up and running, but creating something new, even though it's the second phase of something that exists, always requires setting things up like new web pages, maybe a new graphical profile that we did. We have been doing quite a bit of reporting to Vinnova. They now require 2 reports per year, so we've done all of that. We also have a new tracker that tracks all our activities, publications, presentations, events, courses, all of that we have to report. So a lot of things under the hood that you have not been seeing, but that we have been quite busy on. So we are now in the phase 2. We're actually quite a bit into phase 2, already 1.5 years. So we have 3.5 years left of the center, which means that's a lot of time. But in another sense, it's not that much time. So to get things done, to realize this vision that we have for DTCC, we have to be working hard for the coming 3.5 years. We have around 35 partners. That's around the same as we had for the first phase. And we have, just as we did in the first phase, we have 10 projects. We have 9 projects or 10 projects also in the first phase. And those projects are now all up and running, and we will be hearing about those projects after lunch. Our portfolio of projects is on track. So all of these projects are on track in the sense that they are where we expect them to be. Some projects have started late due to recruitment taking time, but that's part of the plan. So we will be listening to those projects later after lunch when we have the project portfolio presentation. So what is different in DTCC2? Well, this is influenced by mostly, or to a large extent, by the report that we received from the evaluation committee from Vinnova. They have some recommendations for us that we agreed with. It's also based on our own self-evaluation and our experience from DTCC1. So higher TRL, of course. So we've been working with this now for 5+ years, and we expect our methods, our tools, our softwares, our processes to mature and become of a higher TRL, so that we can actually approach our partners and say, hey, which problems do you want to solve? Give us your data and we'll get back with a solution. So no longer sort of talking to us and then we'll get back in 5 years and say, we have something we can try out. So we can say now, due to having worked with this for 5 years and other developments that we'll get back to relating to AI, we can actually deliver things much quicker now than we could in DTCC1. Increased end user focus, that's in combination with higher TRL. International reach, so more focus on international collaboration, going for international grants and so on. Also establishing networks with partner universities for our PhD students so they can collaborate internationally. Increase scientific quality, so that was a recommendation to focus more strongly on publishing in high quality journals. So that's something that we are emphasizing for DTCC2, and also connected to higher TRL and end user focus, a maturing software platform that we will be talking about again after lunch. So we have 10 projects in DTCC2. We have 9 milestone projects plus the platform development. And you can see them here on the slide. So they are grouped into different categories. We have circularity and reuse, reclaimed, redesigned, and retwinned by Malgorzata. Then we have projects that Matthias is leading, focusing on BIM, different aspects of that. We have urban analysis with 3D city modeling. So that's about generating, preparing high quality 3D models for visualization and analysis and simulation. We're still working quite a lot with mixed realities, different ways of presenting and discussing and communicating around data. Digitizing trees is another interesting project that Franziska will be talking about after lunch. Digital live building twin, it's still there, but we're discussing maybe we will be tweaking this into a different project. And then we have projects on the bottom here working with aspects of platform development, software development, and AI in combination. So this is our platform or our project portfolio, and all of these projects are on track or are at where we expect them to be. So some of these will be starting after the summer due to recruitments now being in place. And the projects are on track, and also the budget situation. So we are reporting every year to Vinnova, and this is what it looks like for the main 3 partners in terms of spending, Chalmers, FCC, and CIT. So FCC and CIT, they are on track. They have been sort of producing as much in terms of costs as is expected from the budget. Chalmers is lagging quite a bit behind, which means that we will not be worried about this, but we need to worry about it a little bit so that it doesn't become a problem in the future. But we think that we will be seeing much better numbers this year after now recruitments being in place, and we can start spending, and we have all the personnel in place to do what we promised, both in terms of delivering project results and spending money, which is sort of what we report to Vinnova. So we have to spend in order to get funding. And this has been approved by Vinnova, so there's no worry here, and we'll get back to good numbers for Chalmers next year. So it's about recruitment mostly. One important thing, one big change for DTCC2 compared to DTCC1 is that we now have a much stronger focus on recruitment of PhD students. So this is from our PhD forum inauguration a couple of weeks ago. And for DTCC1, we had a different structure. So we didn't spend that much funding on PhD students. So we rather spent it on the research groups that brought in their students and personnel into the project. But now this time we said, let's mainly focus on creating projects when each project is centered around one or a couple of students and postdocs. And that's what we've been doing for DTCC2. So the target is to have 6 + 3 PhD students, 6 academic and 3 industrial PhDs. We haven't really done that yet. We actually have now in this forum, we have 9 PhD students and 3 postdocs. So we have quite a sizable group of students and postdocs in this forum, and this is being led by Leonardo Rosado from Chalmers, and the idea is to have common workshops where we can discuss common things, touch upon digital twins, research communication, and feel a belonging to DTCC between these students who work at different departments at Chalmers and FCC. We also want to establish a partner network with our partner universities in DTCC, so we can have exchanges. Our students can go and visit other universities in DTCC, and we can host students from other universities at DTCC. So this is one important aspect of DTCC, the focus on PhD students who can be the main drivers for the projects that we are working with. Another thing that we talk a lot about is our platform development. So this is something that has matured considerably over the past year. The vision has been the same the whole time, which is to go from raw data, open raw data in terms of like anything we can get our hands on, and taking that into our platform to have a common representation of the data, to be able to transform and generate data based on these data sets, combining them into higher level data sets, doing advanced analysis, advanced simulations, and then presenting these results in the ways that they need to be presented to be effective in terms of communication. And this has been accelerated over the past year using AI. That's something we get back to in the panel discussion and after lunch, so that we can now sensibly talk about, we can have like any data sets, because this bottleneck that we had before, that we have to, okay, it's an API, we have to work with hundreds of APIs and they're all different. Well, that's not a problem, because we have AIs that can help us figure that out. So things that used to be practical problems in terms of talking to many different data providers, that's not an issue anymore. We're also working quite extensively with different interfaces. So that this AI-generated image here as a placeholder for our 3D table that we're building. We actually built already one of those. We're building a new one. We're building several tables where we can have this as an output, where we can, whatever we have here, whatever raw data we have, whatever kind of simulation or analysis we have, that's something that you can interact with hands-on in this physical digital twin, or through an AR experience or VR, or in a web browser, or on your desktop, or in Unreal Engine, wherever you want to consummate your data. You can do that in a nice way, and it also feeds in this pipeline where we have the platform taking you from raw data through analysis, simulations to visualization. This is something we talked about already, that AI is changing how digital twins are being built and used. There are challenges to this, of course, but we try to stay on top of things in terms of using the best tools available and using them in responsible and effective ways in assisting our development. in assisting how our users can interact with our platform. So this adds a layer between users who are not programmers and the platform, where they can ask questions in a natural language and get validated answers. So this is something that assists both the users of the software, but also the development of the software and connecting things. So something that I want to emphasize now, I mean, this is again our platform development, but it also applies widely and more broadly to all our projects. That what we need from you now, from the partners, we need data, we need sites, we need problems that we can use to validate our simulation. So we have a lot of resources in terms of data, in terms of software, in terms of methodology, and what we are looking for, and that's something that we have been working actively on during the spring, to get in touch with all our partners and asking them, what data do you have, what challenges do you have, how can we build solutions and try things out, build pilots, build test cases. So if you as partner, if you have some data sets, if you have some challenges, if you have some use cases, so let us create those together as demonstrators for the methods that we are developing. And hopefully we'll have something. I mean, the goal is that by the end of DTCC2, we'll have method software that we have created together with our partners that are in actual use, solving real world problems. And I think we can actually get there in terms of delivering these artifacts that we need. So I think we are a little bit ahead of schedule, but I think that's fine because we can give more time to our invited speakers.
Yeah, or give you some more time to answer some questions, actually. So if there are questions to Anders, please ask them either here in the room or online. Yeah, there's one in the back. Maybe not.
Christina?
Facilitate with the microphone here. One second, waiting for a sign. Is it?
Let's try. Yeah. Now it's good. Thank you. Thank you, Anders. My question concerns where or what do you see as the biggest challenges for this period? You talked about higher maturity, but still reaching very high quality scientific publications. Where do you see the challenges today?
Well, I mean, I think that's the things that you already pointed out in your question. I mean, those are the challenges. It's a challenge to deliver something that is an end user solution, and at the same time creating something that is has a high scientific impact. Because if you do something very groundbreaking, sort of lower level, that sort of comes before the packaging into a product. But I believe we can assist that in terms of having built infrastructure and learn from DTCC1. So we have something to build on from DTCC1. So for example, we have a PhD student coming into the Department of Mathematics at Chalmers, Mathematical Sciences, and the focus of that project is to create new methods for generating high quality validated 3D geometries. So that would be a mathematical thesis. But that person comes in to an environment where we spent 5 years building infrastructure and software. So in that case, we can somehow I can say, isolate that student from the overhead of building software, working with the data, figuring out the interfaces and APIs, and focus on the research project. But that person will come into an environment where, if it all goes well, I mean, every new sort of progress made on that research project will be immediately sort of put into use in the software, because the person comes into an environment where we already figured that out. So that person starts from somewhere and builds in terms of everything that needs to be sort of added around a research project to make it into, I won't say product, but something that is useful for our end users. So it's a challenge, of course, but we are aware of those challenges, and I think we can get it done. Nicholas.
Yeah, thank you so much, Anders. Always great to listen to you. Do we do this in English or Swedish, actually?
English.
Okay, great.
We're in the right language.
Question, end user.
Yes.
What is your definition of end user? Is it academic, or after these years, the second stage? Is that also SMEs, companies, or what is the definition?
I would say the end users are SMEs, companies, and municipalities. Those are the end users. What we've been doing so far, I mean, in terms of software development, that has been like other academics. Those have been the end users. But we now have a much stronger focus on end users who don't need to be programmers. Of course, everyone is a programmer today, so it's not a problem. So in a way, AI solves this from both ends, right? So in a sense, anyone can be a programmer. And from the other end, it's easier for us to create interfaces that allow people not needing to like install a Python package. So end users, those are people who actually are the problem owners. They want to solve a problem, investigate the problem, solve something, compute something.
Thanks.
I actually have maybe a reflection more to Christina's question on the innovation aspect versus application. I think we also need very courageous partners that can actually be willing to adopt innovative solutions. So somehow we have to meet halfway between cutting edge research and then cutting edge application in practice. So I think it's kind of going both ways in a way. It's not enough for just one side to be active. It has to be two-sided exchange, I think.
That's definitely correct. I mean, you have to have a will from both sides from the researchers to try to step out of their comfort zone, and also for our partners to step out of their comfort zone. And I think we have courageous partners in the center. Thanks. Cecilia, you have a question, right? Yeah.
Yes, it's about data connections and broken links, because we have a workflow internally at Liljeval Architects based on an API from Lantmäteriet. And then with a 2 weeks notice, they changed the API. And we have to spend a lot of time reworking our workflow. Do you have a strategy for those kind of broken links, or how you collect data?
Yeah, I mean, so did you try just sort of talking to an AI, please fix it? Because I mean, in my it actually works. I mean,
Yes.
In my experience, you can say, please fix it. It's broken, and I mean, I experienced that a couple of times, and it's been amazing how quickly it actually detects and tries things and figures things out that would take me maybe a week, and it does that in like 5 minutes. And if it doesn't work, you can just sort of try harder. I mean, that's.
Okay, I'll tell my AI to work harder.
Yeah.
Thanks.
Thank you so much for your presentation. I actually have 2 questions. One is about data quality, because digital twin or AI is an interface. It's not a real kind of engine. So, and to make this kind of interface work, we need to have a data quality. What is your way to work with the ground data and data quality, data cleaning or pre-processing parts?
So, I mean, that's something that we will be talking about later, but we have this concept of data sets. So we have been working during the spring to create these sort of large collection of data sets. And these will be like curated data sets with some kind of guaranteed quality. And it's very much domain specific. So if you talk about, for example, simulations, so there are many things that you typically talk about when you make a simulation. You talk about accuracy, convergence, verification, validation, all of that. And that's something you have to do. So all of those things, and I would add uncertainty quantification. So all of those things that are part of and have been part of scientific computing for 50 years. There's a lot of literature and a lot of work on those aspects. So it's very much suited to those questions that you're asking.
But then I can come to the point, sorry, it will be a little bit debate now here, because by definition, digital twin originally was never a simulation base, it's rather actual data processing platform. And in this case, one thing is simulation data set, another thing, the actual data analytics. How do you work with actual data analytics?
Well, I mean, I would say, I mean, so let's get into maybe a little bit of debate. I would say that that's something that we typically present when we talk what is a digital twin. I think it includes this ability to make predictions. So some kind of simulation is needed. You have to be able to make an experiment and ask a question, what if I change this? What will happen? So some kind of simulation or prediction is needed, either from classical simulation methods or from AI predictions. But I would say it's the same kind of question that we've been working on in the scientific community around scientific computing for many, many years, which is about validation of your results. You have to test your results. You have to make experiments. You have to, like we did for, I think Desi will be talking about this for our wind simulation. So actually going to the Netherlands, as we did, and making a wind tunnel experiment to validate our simulations on the actual city geometry.
But then, okay, this part, I agree, it's important, but then the actual data analytics, how do you work today with the actual data? Like,
what do you mean actual data?
Like if you get data from sensors, if you get data from like mobile phones, like actual data from the monitoring systems to process it and include to digital twins, what is the...
You mean, how can we guarantee it's accurate? Or
I mean, if you measure temperature on the ground,
yes,
you have 7 different sensors to also validate that this is accurate from satellite, from the weather station, from the ground sensors, contextualized data. This is more like the ground data, which is rather not simulated, but come from the physical parameters measures.
I mean, that's also part of, I mean, if you want to make whatever you do, I mean, I would say that you don't want to, you don't just want to present raw data. You want to present like some kind of result. You have to make some kind of analysis. And then that's about uncertainty quantification. So you have some uncertainty in the input, which propagates into the output and gives you some kind of uncertainty in your in the answer you get. Sorry. And in order to do that quantification, you need to know something about the uncertainty in your input data. And that's something I can't really answer. I mean, I come like before, like after that. So I need to know something about the uncertainty in the measurements. Of course, we can make assumptions, but again, it's something you have to measure, I would say.
Thank you so much.
That's a very good start. A lot of questions already
I think it's time now for Thomas.
Yeah.
Yes.
Thank you, Anders. Very, very.
Yes, thank you.
Good. So now let's go to our first keynote, who dives into what I feel is one of the most exciting shifts that we now see with AI, and that's making complex data models more accessible to everyone, and not just engineers. So please welcome Thomas Kolbe, professor and head of geoinformatics at TU Munich, also member of our international advisory board, and many things more. Guten Morgen, Thomas. Wie geht's?
Guten Morgen. Es geht gut, so it's fine. Can you hear me?
Yes.
Okay, great. Thank you, Bernd, for the nice introduction, also for inviting me. That was a very good start. Also, for what I heard already, there's a lot of questions already asking the right, going in the right direction. And I'm also especially happy because Anders already made a point in his introduction and saying we can now use AI to make all of this much more easy accessible. And this is basically also my presentation about, however, with a stronger focus on 3D city models. And I also intend to have an online demo. So everybody, please keep the fingers crossed. I will present a prototype that we have just released as open source. And so, yeah, let's see if it all turns out fine. Yeah, so actually, virtual 3D city models, that's the main topic today. However, I will talk quite a bit about large language models and different ways of how to utilize them to assess and access 3D city models. And First of all, yeah, these virtual 3D city models, they represent the physical structure of our built environment. And here to the right, you see different examples in different levels of detail. On the top, you see a level of detail 3 building model that has basically already details like windows and doors and also balconies and other aspects which are included. But of course, city models can also extend to the interior. So it's not just BIM that looks at the interior of objects, but it also is in city models. And so therefore, we can also have interior representations. And below, you see it's not just buildings, it's also facilities that can be represented and that are represented as city models. And typically, city models, in contrast to BIM, they are not just covering a project site, but they are typically covering at least a city district and may, however, reach up to entire countries. And the nice thing is that typically virtual city models are being used to represent the as-is situation, so the current situation. But of course, you also can track the history and see what was the city looking like and what was the city model looking like at specific points in the past. But of course, you can modify, because this is a digital data set. Why don't you simply clone it, and then you can modify whatever you want on this city model? So you can basically tear down buildings, you can create new buildings, you can plant rows of new trees, etc., all in the digital world. So that means the digital model looks like reality if already everything in your planned measures have been realized. And then, of course, you can run the same kind of assessment tools, simulations, etc., on this virtual representation of the future. And virtual 3D city models are really a key component in urban digital twins. They are not the digital twin itself, they are just a component of it. And however, they are quite important because if you visualize something, then the 3D visualization of a city model really conveys the spatial concepts in a very intuitive and easy to understand way. And as I already mentioned, semantic 3D city models are important sources for analytics and simulations. Maybe one word on the about semantics. I mean, these models that you see on the right could be just computer graphics. But if every object knows what it is, so I am a building, I am a balcony, I am a window, I am a specific door, then you can also really utilize these kind of models for many analytical tasks, and I will later on show some demos. Now, the problem with these city models, and first of all with cities and the models, they are complex. And we all know that cities consist of many different objects. So, and every of these objects, if we take a closer look, they consist of components. These components consist of further components, etc. And that can be really quite a long aggregation hierarchy. Then, of course, these objects have diverse thematic and also spatial properties. So we may have different geometries assigned to the same real-world object. However, the real-world object can have a lot of different attributes or properties that we can also assign to these objects. And typically, these objects are also interrelated to each other. We have spatial interrelations like topological connections. So that building is touching that building, for example. But we also have all other kinds of relationships. And in the end, such kind of city models then form also a kind of urban knowledge graph. And the good news is we have standards which basically take care about how to standardize and how to represent these different city models. And 3 years ago, I have been in Gothenburg. And I also gave a presentation which much focused on city GML. But of course, I have seen the BIM domain also is very important. And these standards, however, allow to have a lossless representation of these complex data. And they also allow to exchange that rich information without losing information, which often occurs if you boil it down to using other exchange format like GeoJSON or shape files or whatever. So it's the problem, however, is that the complexity of reality really is imprinted into the digital representation. So that means these data models from CityGML and IFC are not too simple, I would simply say, and I would admit. But the problem is it's not because the authors of these standards think it's very cool to have these complex standards. No, reality is complex. And if you want to represent certain aspects, you cannot really get around this. And that's basically an issue. And so if you want to analyze these complex data structures, you have to understand them and you have to know them. And that, of course, is an issue. And professional users, They understand the tasks that they have to do. They know what information they need to perform, but typically they are not knowing how to retrieve such kind of information from an IFC model or from a CityGML model. So there's a huge gap between these two things. And one possibility to bridge this gap, I hope you can see this animation. That's a very simple visualization of a 3D city model. And that allows you, for example, to use something like a web browser with a 3D viewer. And then by clicking on objects, you can, for example, look at the solar energy potentials, the heating energy demand, but also you can possibly see what's the electricity consumption of that building over the last 24 hours. So we can already use the city model to link the 3D objects with, for example, sensor data and also visualize that. So that's all nice. But then typically it ends. And it means if you want to do advanced data analytics and planning, so that means you want to not only use the graphical user interface, then you have to know how to basically use and utilize the data models and the application programming interfaces and also query languages. And as Anders already said, planners and citizens aren't experts, at least not programming experts. And so they are unfamiliar with both the data models and the APIs. And that, of course, severely limits the ability to analyze and work with urban digital twins. And now comes the good news, that the new generative AI methods, especially large language models, they can bridge this gap. And so users can nowadays enter natural language queries, and the large language model translates these into formally correct queries for the relevant services and APIs. And then the results are also again processed, and the large language model presents the results in natural language. And so before I then show how we can do this with city models, maybe a couple of words about large language models. And I think most of you know that, maybe some of you don't. So I think it's maybe also a good introduction to today's topic. So a large language model is an AI model that has been trained with a vast volume of text data to, we can really not say understand, but really to analyze and generate natural language. And the key working principle here is text completion. So that means the user provides an initial text like a query, and then this large language model determines the most likely following next word, and that is based on a stochastic basis. And there's also a dash of randomness. And then each subsequent word that is generated takes into account the entire text so far. That means the prompt, the query, and all the words that have been generated by the large language model until now as a context. And so if the large language model then considers the response to be complete, we have an end marker telling basically now I believe the question has been answered. In principle, people are talking about stochastic parrots. So in the end, the large language model is simply choosing from everything that it ever read the most proper words, the most proper syllables, you could say, to produce the output. And however, this sounds a little bit too simple. So typical parrots are just repeating exactly what you say. Large language models, they can really synthesize based on what they have seen before. And there's one more important thing. These stochastic parrots are trained with the knowledge of the entire world. And that, of course, is something that you typically don't have with a parrot. Now, when we look at large language models, there are certain different kinds of large language models. And nowadays, I think one of the most relevant ones are the so-called generative pre-trained transformers, GPT. That's also why ChatGPT is called ChatGPT. And however, there is an older structure which is, however, still in use for specific tasks, which is called bidirectional encoder representations from transformers, BERT. And what is also important is the number of trained parameters. So how large is the neural network? How dense is the neural network? And typically each trained parameter is stored in the end as a floating point value, eating up 4 bytes or 8 bytes, depending on the representation. Typically it's 4 bytes. So, and it means it simply represents something like a weight that has been trained from, or that has been learned from the training data. And however, what we can also do is we can reduce the number of the memory that we need to represent these values by so-called quantization. I'm not going into much more detail here. Another characteristic element of large language models is the maximal context length, or you can say, what is the memory span of a large language model that it can at the same time keep in mind while generating an answer? And that is typically today with the commercial models, it's something around 1 million tokens, which is roughly 1 million syllables. And however, for open source models, typically around 256,000 tokens. And the question is, what data has been used to train the model, and is there any fine-tuning that happened afterward, after the training of the model for specific tasks? Like, for example, you want to use a large language model mostly for chatbots or for programming. And then two important things, which I'm also introducing shortly, is there a support of function and tool calling? And is there support of a reasoning or thinking mode? And I will get back to that in a minute. Here's an example for some commercial large language models. I believe everybody of you knows them. There's only one European model here, and that's from France, which is Mistral 3, which is really, I would say, can really compete with these other models, and however, most of them are coming from the US or from China, and typically the exact number of parameters are not revealed by these companies. It's something around 1 trillion parameters, 1 trillion. So it's really a large number of parameters, and that also means this is the reason why they only can run in large data centers or somewhere in the cloud. That, however, is really causing a lot of problems in Europe, because we have in Europe the data privacy rules, and we also have the EU AI Act, and they basically tell municipalities are not allowed to simply send data into some arbitrary country, which is outside of the European Union, because you have to ensure the data privacy, and you also have to ensure certain risks regarding the EU AI Act. And typically, you cannot use, as a municipality, you cannot use these large language models unless you make a deal with these companies that they operate their data centers in Europe. But that's, debatable whether this is really happening or whether this is really the case. These models, however, are very powerful. They support this thinking mode, tool calling. They also support vision, so image analysis, and they also partly support image generation. Why do I show you this? Because there are also open source models, or open weights models. That's a more precise word. And here's an example from a Chinese model called Qwen in version number 3.6, and that is from the Alibaba Group from China. The good news is it's licensed under Apache 2.0. That means you can use it for commercial purposes, and there's no restriction on it. And the named version, which I've listed here, has 27 billion parameters. So you see, it's not 1 trillion, but 27 billion. So it has 40 times less parameters than, for example, GPT, which of course reduces the potentials and also precision in answers, etc. But as you will see later on in the demo, this is already completely enough to really have a very deep chats and deep discussions about city models. And we have used here a parameter quantization, which basically brings down every 32-bit floating point number to 4 bits. And that means this model is running on my desktop computer in a consumer-grade graphics card. So, the point is actually, because it's completely running on my own hardware, no data is leaving my computer, or no data is leaving my house. That means municipalities or other institutions can run this kind of local large language model in their own hardware, and it reduces considerably any potential issues also with the EU AI Act. So it's that's quite cool. And Qwen 3.6 supports also thinking, tool calling, and also vision. And yeah, we will see that. Now, what is something that where you typically use the large language models? Yeah, first of all, we have text generation in natural languages. That's basically, I would say, the default application. However, on the other side, we can do text analysis and text modification. So we can summarize text. I think everybody maybe in the room has already used ChatGPT or others to summarize some texts. But we can also scan text for specific statements or content, and we can also do sentiment analysis. This is now very interesting. Text translation, that comes really nowadays. I mean, translating natural texts from one language, maybe from German to Swedish, has been really a hard problem for many, many decades. And that's now solved because these large language models, they are now trained not just on German texts or an English text, but also on Swedish text, on Turkish text, etc. And interestingly, you can directly use them to translate. And so that's something I can also later demonstrate in the demo. You can even ask queries in Swedish to even in German stored database with German texts inside. And that's also something that's quite useful. And the text translation goes also from natural language to formal languages. And of course, that is important because we can then generate structured texts. So we can produce tables and formulas using some kind of markup languages. We can produce graphics, for example, using some formats like Mermaid. And what is, however, very important, we can generate program code in completely different programming languages like Python, Java, whatever. And we can create example data. And also we can extract structured data from any input. So if you just, for example, provide an energy certificate of a building to a large language model, you can say, provide me a structured representation in JSON of all the properties that are in there. It will do this. And that can easily be then inserted into, again, an information system. And when the last point is quite important, it can generate function calls and data queries based on natural language. And finally, typically nowadays, large language models are multimodal. So that means they also support image analysis, video analysis, and or speech analysis. And in the demo I'm going to show later, all of the green highlighted parts will play a role. And I will utilize all of these features of the large language model. And now the question is, okay, that was a short introduction, but how can we use large language models now with city models and BIM? And typically these foundation models like ChatGPT or also Qwen, they are not being specifically designed for spatial data and problems, but, and this is the good news, they were trained on general spatial concepts and terms, and also on international geo standards. Most of these large language models know already the details of the standards. And also they are trained on program code to produce such kind of spatial data or to consume spatial data, and the same is true for BIM data. So, and that's something we are really making use of. And in the end, I will come to the conclusion that maybe we don't need specialized foundation models. That could also be a nice discussion point later on. So, we can specialize the foundation models because without retraining, and that's the point. So we can, the geodata and the service relevant information like the data models and the specific API functions, we can convey that together with user queries using prompt designing. You also heard maybe prompt engineering, which is more like something like an art or a craft. And however, if you do this automatically, so we assemble dynamically prompts which basically incorporate the details that are required to talk with specific kinds of databases. And this then becomes part of the context. There is still a problem with the context length. I mentioned that the context length of AI, of large language models, is somewhere between 256,000 and 1 million. But on the other side, later on, you will also see it's not really that much of a problem. And of course, you can also use this kind of data for an additional training step in a so-called fine-tuning. But I will not further go deeper on that part. Now, what is important for large language models? And this is something that is really came up, and it's not that long ago. I mean, it's, I think, maybe 1.5 or 2 years ago that this has been introduced, this idea of function calling. And so if you look and ask certain questions to a large language model, for example, who is the president of the USA? It's very likely that for many large language models, you would normally get the information Joe Biden. I mean, many of us maybe wish it was still Joe Biden, but anyway, so I mean, this is outdated. And on the other side, people are asking questions like, what is this division, 40,366 divided by 439? And then basically the large language models answers with some answer that is wrong. It might be somewhere in the right area. Yeah? So 92 is already close to the 91.949, but it's simply wrong. And also you have things like, if you ask a question like, what is the kebab code? Yeah. Kebab is a dish typically with meat, and so if the large language model can answer, then every order at a kebab restaurant follows a secret code. If you say with everything but no onions 3 times in a row, you automatically get extra meat. And you can really ask the large language model this. And this is, of course, a hallucination. So there is no kebab code defined somewhere, but the large language model makes this up. And yeah, so these are some of the issues. And how can we tackle that? The point is actually, when you see this calculation, the large language models were never designed to compute calculations. They are doing text completion. So what should we do? Yeah, we simply should say to the large language model, if you recognize that there is some computation to be done, don't try to solve this by yourself, but take your calculator and compute the result. And this is exactly what large language models can nowadays do. They recognize, okay, there is a mathematic formula which I need to compute. And then basically they are running a code interpreter, which simply takes that division, for example, generates a Python program and runs that Python program and then takes the result back and gives the user the answer. So that means this function calling, or sometimes also being called tool calling, and that's quite useful. So if you want to answer queries that need current knowledge that was not included in the training data, so if you think about the President of the United States, or if you need specific contents from an information systems, like a 3D city model, or you need contents from non-public documents, which we're not going into the training data, then these large language models require access to external APIs, databases, or websites. And that can be done by function calling. And these functions, they're defined by the application developers who perform the analysis with the help of a large language model. And then you announce to the large language model, I have a function here that can do the following analysis or the following calculations. And whenever the user is asking something that is related to this, try if you can simply create a call to my function. That's basically what these models do. And it shows then the large language model analyzes the user query and first determines whether the result of one or more function calls are needed to answer it. And in this case, the large language model generates the parameter values for the functions and tells the user application which function to call. So that means the large language model doesn't do the function call itself. It simply tells the user and the user application, please call that function for me and give me the results. And after the execution, then the function calls and the results are passed to the large language model as additional context to generate the final response. And here's an example. So if we ask a chatbot that is not using tools, for example, what is the weather in Munich? And then it says, as an AI language model, I don't have access to real-time data, so I can't tell you the current weather conditions in Munich. And however, if we have maybe a tool that it calls a weather API, so that means we tell the large language model, whenever somebody's asking for some current weather in some city somewhere on the planet, make a call to that API, and the results that you get back, send them into the context. And then basically the large language model can answer, say, as of now on Thursday, June 4th, at 10 a.m., the temperature in Munich is 19 degrees Celsius with light cloud cover. Now, the point is actually, when we think about these functions, of course, we can imagine that in the future we have a lot of software and we have a lot of functions, all from different applications, etc. So, and there has been a recent development. It's also not that old, I think maybe 1 year, 1.5 years old, the definition of something that is called the Model Context Protocol Server, MCP. And that is an API that provides functionalities offered by application programs to large language models and agentic AI systems in a standardized way. And this typically needs 3 things. First of all is an MCP host, that is an application software. It needs a server, MCP server, that is the program that makes the data and tools of the MCP host accessible. And it needs an MCP client, and that's a system component that establishes a connection to the MCP server and sends requests to it. And in my demo now, in a few seconds, we will use as an MCP host a database, a 3D database, which stores CityGML city models. And then the MCP server is a new service that we have implemented and which is now released as open source. I also provide a QR code in the next slide so that you can see this. And then the client is basically the new 3CDB agentic chatbot. So we have basically created an MCP server and an agentic chatbot which utilizes that. And in the end, the infrastructure is looking a little bit like that. So we have the user here. The user asks a question. It is going then to this MCP client, which is this agentic chatbot. And then this agentic chatbot subdivides the tasks into further subtasks. And then he also has an array of different databases and tools that he can access. And it automatically makes the selection of the right MCP server and also produces then the queries to the MCP server. The results are going back. And then these intermediate results or the query results are inserted in the reasoning process. And when the agent has finished, it will produce the output, which is then sent to the user typically. And now this is now the something new that I announce here. We have released for the open source software 3DCD database also an MCP server, and that enables agent-based AI systems and large language models to access 3D city models which are stored in 3DCDB, and that database supports CityGML1, 2, 3. And also CityJSON. So basically, no matter what kind of these data formats you have, you can basically connect and import that into the 3DCDB. And then with this MCP server, you can make a connection to your favorite AI tools. What does an AI system learn now from this server? First of all, it learns how the data model of the database itself is defined. It also learns how the object classes and attributes of the CityGML standard are defined. So it also basically gets introduced to CityGML in detail. And also what 3D city model data is really contained in the database and what 3D operators are available in the 3D city database. And we are using the PostGIS extension, so PostGIS database plus the SFCGAL extension. And also it learns how they can run SQL queries on the connected database. And there are also example queries to help the large language model to create their own complex queries. And this is just a slide on the 3D city database. I just included that. I will not talk much more about it now because I would want to keep a couple of minutes for the demo. And however, the 3D CityDB version 5 MCP server can be used in agentic programming environments. So if you are using Claude Code or Open Code, then you can basically develop now applications that can directly work with CityGML-based 3D city models that are managed in the 3D city database, and it will automatically create the proper code and the proper SQL statements, etc. And in agentic AI systems like OpenClaw, so if you just want to run analytical processes, then you can also import it there. And this is the new chatbot, which I mentioned. So that's a demo application that is contained in the server package. It's based on LangGraph and the React framework. And the nice thing is it does not only work with commercial large language models, but especially with locally running large language models. And for that purpose, we're currently using Ollama. If you don't know about that, please Google this. Ollama is a really nice framework, very similar to Docker. So when you use Docker to run your software on your computers, you can run Ollama to run different large language models on the same platform in a very convenient way, I would say. Now, that brings me to the live demo. And let's go. So here is basically, I hope you can see this. This is just not an end user application, but it's simply for exploring the possibilities that you have. And what I have done, I have imported into the current 3D city database this 3D city model. So maybe you see here is a 3D city model of a part of Munich. And this was already shown in the visualization. So we have a number of attributes which are associated with each of the buildings. And now this data is available as a database to this chatbot. And now I can, for example, ask some questions. And I have prepared questions so that I don't have to type them all and simply can use copy and paste. Let me just go to the beginning of this file. You can, of course, ask arbitrary queries, but I simply use a couple of pre-cooked ones, you could say. So, and here I'm now asking, give me an overview of the city model in the database. At what CityGML level of detail levels is the data available? Are the objects further subdivided semantically? And if I send this, it will know, you can see on the right side, there's a log of the agent activity. And since I haven't used it for a couple of minutes, now it first has to load again the large language model. So you can see here, this is my GPU on my computer, and it's currently loading it, and I would say in a short while it should start reasoning. And here you see already the reasoning, and you can also see it creating select statements with certain answers, etc. And now once he's finished, he's going from all of these answers, generating now this answer, and simply says the city model contains 314 buildings at CityGML LOD 2. No other LOD levels are present. While there are no explicit building parts, each building is semantically subdivided into boundary surfaces. We have 314 ground surfaces, 669 roof surfaces, and 2,300 wall surfaces, roughly around that. And now we can, of course, ask further questions. And we can, for example, say, show me all residential buildings in one of the streets. So maybe going back. So all residential buildings in the street Röblingweg. So I'm asking that question, and it should be taking not too long to answer that. And no, come on, yeah. You see, basically, it has already created this SQL statement that you can see on the right, and now this is now the answer that is being provided. I mean, this is at the moment very simple retrieval of data. However, the data is already, as you can see, joined from, I think, 4 different tables. And the user simply has asked, show me everything about the residential buildings. And then I can, of course, ask something like, what's the total roof area of all residential buildings in Röblingweg? So, and that, of course, is an interesting one because it really includes spatial queries. And since the 3D City database utilizes a geometry engine from SF Seagull, we can also run all kinds of queries on 3D volumetric geometries. And now basically he is asking about the surface area, and this is basically the answer. So you can see that query has completely been generated automatically and issued against the database. And you see the total roof area of all residential buildings is approximately 2,500 square meters. Now let's maybe move on to something a little bit more interesting. Maybe we can also say, let me just say, what's the average volume of the buildings in a certain street, for example. But now I will not ask this in English, but I also have created that using a translation tool in Swedish. So let's see if I ask that in Swedish. I hope this is correct because I cannot read Swedish, but and then it should be able to, first of all, answer the question correctly, and it should also answer in Swedish. So that's something that we also told the chatbot. It should always answer in the language that is used for input. And I think that should be right. And here you can also see the query that has been generated. So I think this is already something like interesting. Maybe here is also something that could be interesting. Let me just see. Yeah, let's for example take this query. So I can ask, please provide me with a table listing the gross floor areas of all buildings on Weibrechtstraße as well as the living areas. So now this is again querying for certain data. If, for example, these data are not stored as attributes, they are automatically computed based on the geometry. And that is something that SQL is capable of. And now you see a table of 47 buildings, which are now being shown, and with the different square meters. And this is the house number. First, on the left side, that's the object identifier. And then we have the different values that could be shown here. And finally, however, while it's producing this, I will then ask, can you write a Python program which asks for a street? And let me just go back. Oh, it's still not finished. So can you run a Python program which asks for a street name, then connects to the 3D City database, runs the query, and displays the result neatly in the console? And I can also provide the database details. These are not secret. This is just a throwaway database which I'm using here. Yeah, I will ask this. And now the nice thing is it will definitely generate now a Python code, and you can copy that code onto your local system. And this is basically already a tool. So this means you can easily generate tools which are doing some kind of analysis. And by basically materializing this into a Python tool, you have something that you can reuse. And you can also you reuse that for different queries, in this case, maybe for different street names. And since it's now generating a Python program, it takes a second, but nevertheless, let me just show you some further queries. We also have energy-related data, which is stored for the buildings, like what energy-related characteristics are stored, what are the various modernization measures being proposed overall, etc. So we can ask these questions, or what are the 10 buildings having the least specific heat demands, and what are their addresses and construction years? So these are quite some questions. We can also even ask to produce diagrams in mermaid format, and then they are directly rendered in the browser. But I'm running out of time, and so basically I will probably not show that one. Now let's see. Yeah, it is finished. So you see here now, that is the Python program that has been generated. It even gives installations how you can install it and what libraries do you need. And that's basically the software. And here you can see that that's the query to the database, which is not that simple. If you would have to generate that manually, you would probably take a day or something like that to produce such kind of a query. And that's now really very easy to use with a city model. And no, so let me coming to the end. Maybe just some further words. I did not try this only with models from Munich, but I basically also used this with, let me just see, with BIM models. So I used the IFC data, converted that to CityGML, and then you could also ask something like, do all buildings have interior structures? How many doors are there? Can you tell which doors are the outside doors? How many windows are on the ground floor? And also provide me with a detailed list of the objects contained on each floor of the building. What kind of furniture is in the attic or something? All these kind of queries can be answered then on the 3D City database. And I've also tested this with data from the Netherlands, from the city model of Rotterdam, which is nice because they also have all kind of data about city lampposts and including what kind of LED lighting it is. And so you can easily ask how much watt does the city lighting needs for certain streets in Rotterdam. And that's also something you can immediately answer. Okay, finally coming back to the presentation, and that's my final slide. So as a conclusion, we can say that the complexity of the cities, the data and data models makes it difficult for professionals to effectively and efficiently use city models on their own. And now, however, with large language models, we have very powerful representations. They are pre-trained with general knowledge in various languages. They're specialized on programming languages and queries. The large language model is further provided with the data and structures of the city model via this MCP server. And the nice thing, all of that fits into the system prompt. We have no fine-tuning here. And they generate formally structured queries to the database from user queries in different languages using the analytical functions on CityGML-based 3D city models. And this really means everybody can ask now queries in their own language. And that's also the reason why the title of this presentation was Democratizing 3D City Models with Agentic AI. Thank you for your attention.
Thank you very much, Thomas. Very interesting presentation, and I appreciate the little computer science intro, and then especially the demo, which we always like. A live demo is always the best to have in a keynote. I'm wondering now how we should do. I imagine there are questions here, but we ran out of time already. But I still think we should open up for some questions, and then maybe shorten the podium discussion a little bit. So questions to Thomas. Anders has one question.
Thank you for that great presentation, Thomas. So I was wondering, have you connected the agent, this chatbot, to other things like analysis tools or simulation tools that can deliver other results?
No, not yet. That's basically, I mean, we have been working for 2 years now on this, in principle, on this thing. And I mean, not 2 years really on programming of this thing, but really 2 years of learning and doing things differently. So in the end, and that's the result of it. we are currently just at the beginning, and however, I'm really happy to also hear that in your platform you are using and utilizing MCP. So maybe you could also try to bring that and insert that into your environment when it comes to the question of looking into the 3D city models.
Yes. Yeah, that's something that we are working on. I mean, trying to connect to things that, I mean, then you have this challenge that it might take like a week to run something, right? And how do you handle that? And what happens if 100 users start a simulation on your machine at the same time?
Of course.
Yeah, great. So I'll leave the floor to someone else who wants to.
I have a very quick and stupid question. Have you asked a question like, who's the president of United States with your tool? How and what's its answer? I'm asking because I just want to know how can you make sure that the answer offered by your tool is right.
Yeah, at the moment, as this model currently only uses this pre-configured model, in this case, the demo was just using the Chinese model, which I think has had a cutoff of the training data by 2023 or 2024. So the answer is definitely Joe Biden. But this agentic chatbot can, of course, also include other MCP servers. And one of the MCP servers would be web search. And of course, that means it would automatically also send out a search message to the web, and then would also incorporate that information. So at the moment, this demo will definitely answer Joe Biden. And however, if you would use this MCP server together with others, like for example, if you would use that with OpenClaw or with Claude Code, they are already also doing internet queries in order to incorporate that information.
Maybe I can ask one question. First of all, thank you so much for a very interesting presentation. I think it's really relevant and needed to do research in this field. I actually have two quick questions. One is about, again, connected to the previous question, the trustworthy and validation of a final outcome. What is your plan? Because it's one of the biggest questions from industry. Can we trust these numbers? Because we also know AI, often if there is no data, it will make synthetic data and it's not always the real data. What is your trustworthy strategy?
The trustworthy strategy is that I believe in the future we will see that the agentic AI will produce workflows, and these workflows will have to be validated by a human. So in the end, and I believe we will have something like certified workflows. So the AI is producing something if that hasn't been solved already and if there isn't a certified workflow for something, the AI will produce something, and then there will be a stage where experts can have a look at this and what kind of data is basically combined in which way with others. And in the end, really saying, okay, I would also do it in the same way, and then basically give a stamp on it and say that was basically reviewed by expert XYZ. And that means in the future, we will have an increasing collection of verified tools. And that means if you are a user of a digital twin and you want to ask certain questions, then first of all, the first check will be, is there already a certified tool that you could use for that purpose? And if not, a new tool is being advised. However, you then have to be very careful about trusting it unless somebody has verified it again and put a stamp on it. And so I believe that this will be something like a way forward, because in the end, you're right, I would not trust completely the numbers without looking at the way how it has been generated.
I think it's just a very interesting topic. We had a project with agentic AI for facility managers at Chalmers now, and we met the problem which we didn't expect, not on technical side, but on the social side, heavy resistance of those whose agency is now, let's say, under question. How do you see this topic of agency? Because basically agentic means you give the agency to decide and perform the task rather than just simulate and give you some numbers. Did you start to research this topic of shifting the agencies from human to machines, and how you also see this aspect of resistance from experts actually being kind of, maybe we had this problem of they felt that they questioned their competence. What is your strategy for the social aspect of agentic AI?
Yeah, I mean, we are working together with different cities, for example, in Germany. Of course, one of the cities is Munich. And of course, what is really important is to say we are not looking after replacing somebody. It's very, very important to highlight that and really saying we are just trying to help you to be more productive. And also we are trying to help you to, for example, run tests, run scenarios, which otherwise you might need 4 weeks to envision. And however, with using these tools, you would be able to do this maybe in a couple of hours. And that means you have much more possibilities at your hand. Of course, still not everybody believes that, or everybody is basically happy about it. That's of course that's an important question that you ask. But I can tell you we haven't really done an explicit research exactly on that aspect. At the moment, we have been really more looking into the area. How can we really provide this kind of access to expert users or to non-programmers to this data? And we also have been doing first assessments of the data quality and what large language models work with which parameters and what kind of queries are answered typically correctly. And so we did already some kind of assessments of that, but not so much about the social part. But you're completely right. It's the acceptance. It's a key thing to get the trust of the users.
Thank you. Good luck with your studies. Very interesting.
Question, Eric, and then we come back to you, Thomas, in the panel. Eric.
Yeah, thank you. Hi, Thomas. Eric Jeansson, City of Gothenburg here. Thanks for a great presentation. I wonder a little more about you can call it geospatial AI and the relationship between geographical objects within the spatial world. Have you been working or experienced in language model connected to the spatial relationships between objects in the digital twin, like city furniture versus buildings and streets and so on?
Yes. Actually, as I said, I also did tests with the city model of Rotterdam, and in Rotterdam we have all kinds of objects. So there are buildings, there are lampposts, there are cables, there are trees, so vegetation, including the tree roots, etc. And you can really ask questions about anything, and it also automatically chooses this. And the good news really is, I mean, there's quite a bit of a debate. How do we really need foundation models, geospatial foundation models? And my current, at least hypothesis is the generic and the general large language models are already really good in discriminating and understanding also spatial concepts. And so if you really ask, for example, which buildings are neighbored to each other, then it automatically creates topological queries into the database. And that's so it really means these large language models are already pre-trained also not just with SQL, but also with spatial SQL and the meaning of these things. And I don't really have to explain into too much detail to the large language model what these concepts are, because it's already obviously in their training data.
Yeah, thank you.
Thank you very much, Thomas. We see you back in a few minutes after the next talk. Thanks again.
Yeah.
So, continuing now on the theme of AI integration, we turn to how these technologies actively shape city planning and policy, and we welcome Mila Koeva, Vice Dean of Research and leader of the Digital Twin GeoHub at University of Twente, and also part of our board of directors. Hello, Mila.
Hello, everyone. I hope you hear me well. Thank you very much. It's really a pleasure for me to be among you and to give this talk in front of you and to be part of the event. And I was really very inspired also being after Thomas Kolbe with this nice keynote, because there is some logic also from his talk with my presentation as well. Just a second to share the right screen. Yeah, you see my screen, right? Yeah. Good. Okay. So I will give today a talk about AI-empowered urban digital twins for evidence-based spatial planning. It is inspired also by the fact that I work here in the University of Twente, and more particularly in a department that is very much focused on spatial planning. A little bit more on our university. Yeah, you can just see here that our motto is high-tech human touch, and it really combines technological but also social relevance. For us, it's very important that when we talk about digital twins, we not only think about the technological systems behind, but also we support real decisions that affect people, places, cities, and so on. And in the university, we have many faculties, as you can see on the screen. But I would like to just mention that the work that I will be presenting is being done in our Faculty of Geoinformation Science and Earth Observation. So obviously the expertise comes from this domain, and this is where we always start when we talk about digital twins or when we talk about using AI for cities. So let me start with the fact that cities are a very dynamic living system. And in many planning processes, many planning tools, still in many municipalities, everything is very static. So they often show what exists now and what has been in the past, but are less capable of answering dynamic planning questions. And actually, the presentation of Thomas Kolbe also contributes very much to this component of answering dynamic questions for our cities. So we would like to go forward with questions related to where we can build something, where we can intervene, where we can cool down our cities, where we can perform some actions considering some spatial constraints in terms especially of time. And as you can see on the slide, of course, this can tackle a lot of sustainable development goals. On this slide, I just want to make a small remark that we are emphasizing of shifting the traditional GIS and planning support system to a more focused systems on visualization, data storaging, and AI-empowered really digital twin systems, which move further towards some spatial reasoning, scenario generation, and some kind of co-design with our users and stakeholders. We always work with the users, with the municipalities or governmental organizations that further will use our system. So we try to do that together so that we have an impact and we have something that will be in use after our work. This slide also kind of contributes what was being discussed in the previous talk. We are trying to search for opportunities, to move from static to dynamic system and to move to a more proactive systems. For example, if we have data sets of legal documents and we know where we can do something or where it is not allowed to do something, that with AI digital twin systems, we can kind of answer the question where we can have limitations and where we can proactively, let's say, perform some interventions. For example, where can we put solar panels? Where can we put green infrastructure? Where we can put new development in cities and how this will interfere with the surrounding environment. So basically, we call this opportunity finding. It can be incorporating also the large language models that we discussed in the previous presentation, but it also can have other AI integrated models for that. On this slide, I want to stress that the urban digital twin should not be seen only as a technical platform. We also would like to have it as a public government instrument that combines the initial geospatial data or a variety of input data, but also incorporates knowledge-specific planning knowledge and also incorporates some public values such as transparency, accountability, and kind of fair decision-making, incorporating all this into one system. It's, of course, very challenging to do that, but at least that is the aim when we also work with our stakeholders. This is just a small snapshot on how do we proceed when we develop our systems for our stakeholders. Of course, we would like to try to keep this continuous loop, feedback loop between the physical and the virtual city. So meaning that we try to have continuous real-time data or close to real-time data coming from sensors and observations in the real world. And then we collect the data, we process the data, we analyze it, we visualize it so that we can make some meaningful analysis, and we can perform some decisions based on this analysis. And this is a closed loop. And since today we are talking about AI, AI is, according to us, possible to be used in every single stage of this process, starting from the collecting data, for example, extracting meaningful information from images. This is pretty much the core of our expertise in this faculty. So we extract data, we perform some analytical explorations using AI, we generate dashboards that visualize these results, we do AI harmonization, visualization, and so on. So we try to, whenever needed, of course, to embed help from AI. On this slide, I can just sketch very briefly the usual, let's say, layered approach or layered architecture. Here it can be 6-layer, it can be 5-layer, depends how you structure your models and the purpose of your models. But usually, as I mentioned also in the previous slide, we start with data acquisition, then we move to harmonization, we do some semantic modeling, analytics, simulations, visualization, and very important is the interaction, so that users can really perform their scenarios and their modeling in an interactive manner. They can also do that in a kind of user-friendly manner, so that they can take, let's say, fair decisions based on the AI-generated urban digital twins. Okay, one of the challenges that we were also working on is overlapping with what Thomas Kolbe was saying. How can we use, let's say, text form documents and extract some spatial or link them with the spatial objects? Our work is not so much developed as what was presented in the previous talk, but we have been, because it's quite a complex program, if I could say, all these documents with zoning rules, zoning regulations usually handle quite some complications when you have to link them with geometric models and so on. Recent work is kind of a little bit shifting, at least from our side, more not into text-based and document-based LLMs, but more into spatial and images, because this is where our core expertise is coming from. So let's see what the experiments will go. We are in the beginning of this direction. But now let me a little bit show you on the topic of AI urban digital twins, what kind of examples we have been working on. So we have been developing prototypes in many different domains, starting from urban heat island, energy, waste management, green infrastructure, a lot of air quality and underground water, whether only for water management, but also for emergency response. So there are a variety of prototypes that we have been developing in different TRL levels, depending on the project, depending on the stakeholders and the data input available. However, urban problems are not always isolated. So we started first tackling them as isolated solutions, but now we go much more into analytical engines in digital twins that try to combine multi-model simulations. We start with two as possible, two domains, because many models with different domains are really, really hard to bring into one system. But these are the, let's say, recent examples or recent tries in our work. I will show you some examples that illustrate the idea of generating architectures that can tackle, let's say, multiple domains. For example, this was work in our city here in Enschede, where our university is located, and it's a prototype that combines energy and ecology indicators. We tried first on a neighborhood scale, but the idea is that it can be performed easily on a city scale, and the idea is also to make models that are transferable to other cities. So everything is open source, everything can be really scaled and transferred later. The main idea is to tackle the conflict between rooftop solar potential and also the need of greening and cooling through vegetation. So we try to integrate this into a digital twin system, trying to look at the optimization of energy use and prioritization for solar panels and rooftop exposure. We were looking at many different ways to optimize this in this study, like looking at the reality, the trees, the shadow that trees are having, the shadow that trees are covering actually on the rooftops, so that they are reducing the solar potential. So all these trade-offs have been, let's say, looked in this prototype. Yeah, it's a video that I'm now showing that is actually showing you the prototype. It can run in 3 different languages. And you can see here also the KitKat and the QR code. You can look at it for yourself. Yeah, let me a bit speed up this video. These are all the trees with their exact location and semantic information. And basically there is explanation of all possible scenarios that you can do. If you look at the right side of the screen, you can have different type of trees. Their crowns are different and the simulation of their growth is being discussed. Also the roots under the ground. So basically, if we decide putting new vegetation, new trees or new parks or green areas, what would be the effect? Also some kind of well-being corridors in relation to vegetation is being simulated and calculated. We also got a request from the municipality, what if decide removing vegetation? How would that affect? So on the CO2, on the cooling or so on. What if we decide to put blue or water bodies? Or what if the green is on the rooftop or on the facade or green gardens, and so on. So all these projections, all these scenarios can be done also with real-time data and real-time sensor data provision, but also weather forecast, let's say, embedded in the system. And of course, this is just a prototype based on the wishes of the municipality, but it can be further explored and upgraded. Multi-criteria decision support system has been, of course, developed. And what is the good part is that we managed to do it in a kind of user-friendly manner, so that all the programming behind, all the Python is very hidden. And the municipality workers can only play with values. So if they want to make some cost-benefit analysis, they can literally put the values themselves numerically, and they can see their predictions and simulations instantly. So there is no need of, let's say, deep knowledge. Here was also a small AI assistant embedded, but this is just a very simple version, answering very simple questions, only to demonstrate that this type of stuff also can be integrated. In case we would like to do more, of course, this can be further developed. This is the part of the prototype that is showing the energy potential and also the solar panel potential. Similar questionnaires and similar scenarios can be done also in terms of solar potential. Again, I'm a bit speeding it up, but for example, here, if we mark a certain number of buildings and we decide putting solar panels, what will happen? Also, there is a simulation in relation to energy sharing that is now visualized in this prototype. What else I can show? A lot of visualizations, a lot of simulations. And here is the cross-domain, let's say, analysis. It is more on a statistical level rather than visual, since it's quite complicated formulas behind. But of course, visualization can be done. Here was the menu where I was mentioning that you can simply add your values and simulate the and assess your costs, interventions or simulations based on that. Of course, the workers can export their results in PDFs, in JSON format, in graphs, and so on. So this was just one example that I wanted to show you. Let me go to the next one. This example moves from a city or neighborhood level to a building level. It has been done in a collaboration with our dear colleagues from GATE, from Bulgaria, from Sofia. You will have a keynote speak later today in a program from Dessislava. So we work together with her group in Sofia for the building of GATE, because they have a lot of data that can be used for these experiments and these prototype developments. We were looking at web-based 3D digital twin for energy management in a smart office building. We connect here building sensor data with 3D visualization, energy monitoring, forecasting, and also role-based dashboard. So you can see that we have different roles, different, let's say, users. There is, of course, a small AI facility assistance embedded. You can see also on the right side of the screen the technology stack. I am not planning to go into much details. It's just a small visualization and small demo. So yeah, we call it Gate Digital Twin. You can see the different users, building developer, facility manager. The data is really quite detailed per room, per energy circuit, and is also showing everything in real time in a detailed visualization. You can look at the temperature, CO2, humidity, all this can be simulated, analytics can be performed, metrics can be assessed per room, per circuit, and some kind of quite smart estimations can be done also for future predictions. So that is the good part of the AI embedded assistant in this digital twin. What can I mention also? Yeah, you can see, for single room, for the elevator, also for the chargers around the building, for the electric vehicle, all this can be simulated and can be predicted. Also, the information from solar panels is embedded apart from the indoor settings. And here are also some kind of a chatbot that can also give some small question and question answers in terms of energy usage and predictions. It's not very advanced, but it can at least show the possibilities of such kind of systems. What else can I say? We have done a lot of other AI analytics embedded in digital twin systems. For example, this is in relation to urban heat. There are so many examples we've worked on urban heat. This one is also done for Sofia with Gate, and there we started with assessing how can AI help, since the weather research forecast can be really complex and data intensive. So it raises questions, can machine learning or surrogate models support faster scenario testing? So the idea or the aim is not necessarily to replace the physics-based modeling, but it was more to explore how AI can make urban heat analytics more scalable or more accessible. So we were looking here at 10 weather stations in Sofia. We were assessing the mean temperature. There were quite some correlation coefficients for temperature that have been analyzed, and of course, in our case, the machine learning performed quite well. We used just a simple random forest model for this particular experiment that achieved quite strong performance and in terms of predictions, you can see. But this was a really interesting study to look how can we use machine learning for urban heat, and can we scale this to other cities. We have been also working on more local level here. This is a work in our city in Enschede, where we were using the sensors on ground and weather conditions, again, are predicting heat. So here users can put vegetation, put water bodies, or assess, as I was mentioning in the previous presentation, buildings, green roofs, and surrounding, so that they can assess the heat. Similar work was done here for Padua, again simulating with 109 sensors on the ground what will happen in our surrounding if we do more green or more blue infrastructure and it was simulating the heat and also doing some cost-benefit analysis. I'm a little bit scrolling faster through the videos because they have the same ideology behind, just different applications, different prototypes for different cities. We have been working also on air pollution. It is just, let's say, initial studies related to predicting air pollution and communicating with stakeholders on simulations and predictions. Here it was again work in Sofia, measuring historical data, but also real data about predictions. There was again AI model embedded. I'm just showing most of the examples where we used some kind of AI models that are using data for predictions and simulations. And this was the application that was developed just for the users to see the weather, the sensor stations, and to see what kind of predictions we can make in terms of pollution and spatial distribution, of course, on the predictions, simulations, and numerical values, of course, visualized with different graphical and numerical distribution. It was a very nice exploration, but to be very honest with you, I think we should combine it also with more physics-based modeling so that we make more accurate predictions and more reliable, let's say, simulations for future work. We've been working a lot on water management in terms of global scale in relation to, let's say, flood simulation, vulnerability analysis, and looking at the type of buildings where there what will happen if there is a serious water or water flooding, where, let's say, are the most the buildings that are in high risk of being flooded, and what interventions we can have. You can see here there are simulations in terms of 2 hours, 24 hours, 48 hours in river flow, or and different scenarios. This is the work done in Dominica, in Caribbean island, so a lot of simulations in relation to that. Just a second, I had some slide that was not being shown. How much time do I have is my question. Why this slide was not
slowly
shown?
but surely, if we want to allow for some questions.
Yeah. Okay, I will just show this slide. I don't know why it was not shown when I was talking. It's related to water prediction as well. It's a nice example where we also used 2 types of water management predictions. One was outside. If you see the right side of my screen, there we were really predicting when the level water will rise, automatically to switch on and off the pumps in reality. So this is a work done again in our city in Enschede, where we are now. But I want to also show you this very, I will speed up the video, this work on a very local level, which is example of the drainage system. So these green, yellow, red dots are along one street, and they show a blockage in the pipes in the systems. So basically with our AI digital twin, we are monitoring and we are controlling the drainage system in real time. And also this can be performed in every street of the city. So the graphs that are shown on the right side are showing the groundwater level and the pipe barriers. And the red line represents the level of the groundwater. And the purple line shows where the level touches the ground. And this big number, which is a dynamic number, if you see I can move it and it changes continuously, is showing the appropriate, the number or the position of the barrier and how close and how open it is in real time. So basically this is what we are controlling in case of water flow underground. Yeah. That was the example kind of was missed in my presentation. So I want to just close this keynote with the last slide where we really think about AI digital twins. The PowerPoint crashed, but no problem. AI digital twin in a more global scale. We look at it more into how to combine multiple domains in one system. What is the interaction between one and another domain? What kind of influences, what kind of AI support we can embed? But all this we try to do in an openable, shareable way, and using standards, using common infrastructure, so that we can really scale and transfer in different cities. Yeah, thank you very much. I hope it was interesting for you. Yeah.
Thank you, Mila. Very interesting. And you're so productive. Wow. So many prototypes and applications that you built. I think we allow for a couple of quick questions and then we'll start with the panel discussion. We've got one question there. That hand was first up and then another question there. Okay, yeah.
Thank you very much for your really interesting presentation. So you mentioned about the flood risk assessment and water inundation during, for example, floods. And I was curious to ask, so how this is like your platform is able to understand, for example, the inundation level on the surface or below the surface, as you mentioned about drainage. Is it like done by performing analysis or is more by data? Is like by simulation, I mean, or more like by data analysis that this actually can be processed and understood?
All our models are, this is a very fast and easy answer. All our models are data driven.
And so about this, so I have a question, because you mentioned, for example, some areas, I think about in the Caribbean or some, we are talking, if we think about some areas that they have less data, okay, because maybe, for example, in where you are, you have really great monitoring data and it's possible to use that, but if they don't have data, so then how, for example, this can be addressed?
So we are working a lot with countries that are not in Europe. This is also very important for our faculty. And for example, the Caribbean project was an ESA funded project, so from European Spatial Agency. So there was a lot of remote sensing data involved in this project. But the idea behind this is that we developed so-called fast flood mobile application. I can share the link later if you're interested. That is an open source platform that is using openly available remote sensing data. And of course, for our concrete digital twin simulation, we went from global to local scale. So there we, in addition to the open available remote sensing data, we already collected with drones and with the locally provided data from the municipalities, a bit more detailed model so that we build our flood simulation. But the whole ideology behind this particular application is to use as much as possible the open available remote sensing data integrated with the weather forecast and rainfall estimation and rain data that is also available. So it was all about data-driven approach, right? But usage in stepping very seriously on remote sensing data.
Okay, thank you very much.
Yeah.
So 2 more quick questions and answers, and then we'll go to the panel.
Yeah.
Thank you very much for the very interesting talk and the very impressive demonstrators. So we're also working with urban vegetation and especially this multimodal simulations or the multifunctional analysis are of course very interesting, and we're also exploring that. So my question is, do you see that the stakeholders engage with that? Because what we have learned is often they are focusing on accessibility, for example, and then sometimes you have some particular questions, like, for example, can vegetation be used as a measure for improving air quality? Or I have a very windy place, so how can we work with the wind? But not this integrated approach that you are thinking of and that you are working with.
To be very honest with you, we start always with their wish list, we call it. We go to the municipality, we talk with them, and we collect all their wish list. And sometimes their wish list includes only one domain, as you were saying. But many times we need to integrate 2 domains like energy and green, or urban heat and temperature and energy. So sometimes to answer their questions and their wishes, we need to integrate this domain, and this is where the hard part comes, because when we only focus on one domain, we can go really deep and we can really develop it more precise, more accurate, and go in depth. But when we start doing this in multi-domain combinations, then it becomes really complicated. Yeah, so for example, now we have a municipality that is asking us to combine the outside with the indoor. So this already triggers pretty much complication because and it's also related with heat and temperature. So we were thinking how to approach this type of request.
Okay,
but we
great,
start always from that approach. What do they want and how should we reply on their wishes?
Yes, thank you very much.
All right. Last question.
Actually, expected question about CFD from Francisca. Do you use wind CFD model in your heat island model? Because we know that adding trees increase the shadowing, but also it can decrease the air velocity in some cases, which also impact the building physics of the near buildings. Do you have this wind simulation CFD model?
We didn't go to that direction so much. What we have done is to use the wind direction and the wind speed. That is what we were looking at. But we didn't go into the simulation. So the idea of, for example, that approach that I was showing for Enschede here for our city, we were looking at the temperature, the shadow analysis, visibility analysis, wind, and we were simulating the orientation of the building. So if they want to build new buildings, where should it be so that it doesn't block the wind? This is what you
Are we
were
talking about surface temperature, also on the ground, also on the facades?
Ground. So on that one, and that particular one, we were looking at the ground. So there are other studies that we use only remote sensing data, where we look at the surface temperature and cross city, let's say, influence. There it's more on a different scale. But for the wind, particularly as you're asking me, there we were looking only at the ground.
Thank you so much.
On a very local scale. Yeah.
Thank you, Mila. So we now get to the panel discussion. We're setting the scene for this, moving the camera, and I'd like to have Eric here, Eric Jeansson from the city of Gothenburg, Mr. Digital Twin of Gothenburg, I would say. So please have a seat. And Anders, you know already, and Mila and Thomas, you will join us as well.
Yep.
Microphone working? Yeah. Okay. And the other microphone was... All right. Good. So now I've got a problem. You already asked all the questions that I had prepared here. So you gotta help me a little bit with the questions. But let's start with you, Eric. Very simple one. Where are you on your AI journey?
A simple one. Thank you. This is an endless journey. We're actually building a semantic digital twin called Virtual Gothenburg, and it's based on all the geodata that we already have within our departments within the city. And as I said, it's a semantic one, and we use a kind of parametric procedural technique to visualize the geometrics of the city, of the urban environment. So the twin is based on CityGML and the structure of that, and we're into phase 2, you can say, and we're starting to delivering the digital twin for the urban planners. That's our goal for this year, through some kind of pipeline that you can actually import the digital twin to your own tools like Forma or Rhino, that kind of tools, and also working on some kind of cesium application or more light application for the urban planners for visualize the urban planning like solar perspectives and so on. So yeah, that's an ongoing project. Never-ending story.
Can't imagine. You saw Thomas presenting, some very convincing, tool calling, and democratizing in a way how we use digital twins and AI. If you get these tools in your hand and they're open source, where do you see some problems implementing that actually? So when you go to your politicians, give us money, we want to implement this. Where do you see the bottlenecks in the real world?
Yeah, you actually said it. It's just the financing the project itself. We struggle in municipal organization. You have this kind of hierarchical structure, and we don't have the culture of innovation within the municipality. So I think it's more like a strategic problem. We need politicians and directors of the different departments that actually understand innovation and that can support us in this journey in creating a digital twin. And we also see that we have needs in all departments, all parts of the city, but we actually make the digital twin in one department, so we have to scale this up within the city, and we don't have actually the mechanisms for doing that. So more like organizational, strategic culture bottlenecks that we see. Yeah.
Mm-hmm. Thomas, I know that you're working with a lot of municipalities, including the city of Munich. Is that something you recognize?
Pardon? Sorry, I didn't get the last question. The last word.
Is that something you recognize from your work with municipalities?
Yeah. Of course. I mean, it's at least I can tell that the processes in 2 cities in Germany are really very well going, and that's Hamburg and Munich. And I think one of the key achievements was social dimension. So basically, the departments, they are not simply created, we are creating this digital twin, but they basically were looking after very concrete use cases with the different city departments, and then were working exactly on implementing that, and that was the vehicle. And then the different departments really, it took a couple of years to establish that. But then one department after the other really recognized what kind of things you could do with such a digital twin. And that was building then trust and also more interest. But it's really important to have this kind of something like a round table inside the city to discuss that. It's a digitalization topic in the end. But I think it's always good to start on concrete use cases that are pressing the other departments, because then you help them on achieving this. But I'm sure you are basically already following in that path. So,
thank you, Thomas. Mila, same question really for you as you work with cities in the Netherlands and also Bulgaria and other. Do you want to add to that? Do you have some suggestions on how to solve these silos and really start scaling all the applications, prototypes that you developed?
Okay, before I answer this question, I wanted just to tell Thomas Kolbe that recently we had very nice collaboration with Wuppertal, Soest and Essen in Germany. So they are following the good example of the big municipalities. So I was very happy to see also what is happening in those small cities. This is just a side continuation of what Thomas was saying. As I mentioned, yeah, we are working in the Netherlands with multiple small municipalities, but also we work quite a lot outside. That is our mission for our faculty. So on the question, I would say that we always start from the needs. And what also similar to what Thomas was saying, what is the pressing need and how can we help them to solve this need? And of course, what you were mentioning, finances are an issue, but we do that with the students. So we try to do that in a kind of easy way, simple, free kind of way, doing first research and giving an open source solution to the municipalities where they can further work themselves with that. I think the key answer on what you were saying is the open source, because with open source, we can help multiple municipalities to work and scale this work, transfer the same examples in between of each other and work in the same way. Because as long as they are linked to a commercial software, then the differences start. That would be my simple answer to your question. As long as we have common infrastructure, common standards, we all follow CTGML, and we try to have common architecture to follow and transfer it around. I think this would help multiple municipalities in a relatively cheaper way without so much finance involvement.
Thank you. I wanted to actually get back to your point, Thomas, about foundation models and the need of them, because I found it very interesting, because if we wouldn't need to specialize them so much, then probably we would solve a lot of issues. So maybe can you maybe make that point again that you started to make in your presentation, and then maybe we get to challenge you a little bit here in the panel. Maybe Anders, you can try to challenge Thomas's point.
Maybe just the point is actually you see a lot of research in many places around the world where people are presenting, training new neural networks, new generative pre-transformers in the way that to say we need a geospatial foundation models. That might be a good way getting forward, because of course, I mean, if you treat, for example, spatial data in a comparable way than image data or video data, so that would go in such kind of a model, of course, the kind of understanding or the kind of interpretation is more natural. But we shouldn't forget that if you want to have a useful large language model, you have to have very large numbers of parameters, and that means, are you really able to train that if you are not Facebook or if you're not Google? And that is a big issue. And so I think there might be good reasons to further. I'm not arguing in abolishing that direction, right? But I'm rather saying, however, please also look what is already possible with what we have and what we can reuse. And this is not just trying or empirically testing or something. So it's a kind of applied research, I would call that, to see how far can we get with the current models, because the current models are so well trained on different languages, on different common knowledge, so common world knowledge. So and that is something that is very difficult to also integrate with an own foundation model. But as I said, I would not talk in favor of abolishing that research, but I would rather say we don't have to wait for it. We can already go ahead with what we have so far.
Do you agree, Anders?
Is this working? Yeah, I think I agree with that. I mean, if you would try to do this, I think it would be hard to keep up with whatever new model comes out, like next week from Anthropic or OpenAI or Facebook or Google. If you did a specialized model and spend a lot of resources on that, you would be beaten next week anyway by someone who has 10 times or 100 times or 1,000 times the resources for training. So I think from a practical standpoint, I don't think it's worth the effort.
Yeah. Let's go a little bit into how development has changed now. So we're developing different software components at the center. The platform development has accelerated quite a bit. Can you maybe describe a little bit now the changes that we're actually going through in terms of formulating new research questions, challenges, etc., scientific excellence, but also in terms of actually bringing or getting closer to production and operation. So how has your team, Anders, now developed actually or changed now in the last 2 years or so?
It's a dramatic change. Everyone is getting like 10 times more capable over the night. I'm 10 times as productive as I was a year ago. I can write 100 times the number of lines of code per day that I used to do, and I actually don't write anything anymore. And things that used to be very important in development, like you could have long discussions about like which editor to use, which language to use, how to format your code, which coding standards, how do you test things, which frameworks do you use for testing, and how do you work with version control. All of that used to be a very large part of software development is now gone because you get that for free. So writing code is free. Writing code in a nice way, in a structured way, using all the best practices for coding. All of that is for free now, so it's sort of goes away. It's no longer an issue. You get that for free. You can count on that. But then you have other problems. It's very easy to do. You've heard this thing, AI slop, right? You can see if you have an AI generated image, and you can see it's an AI generated. You start to recognize it and see, okay, it's just AI generated, and you get the same feeling when you look at code. This is AI generated. So you generate something. It's very easy to generate something. And then you come across other problems like, okay, is this really worth something? You just generated it, right? And things like selecting what to implement and validating that the things that you create, those become much more important, which is good. That's what we should worry about. And then you have other issues like it's so easy to use an AI agent to program, and you start using multiple AI agents. And then very soon you become the bottleneck because you have to make all the decisions. So the human becomes the bottleneck. You're sitting there, you're orchestrating 10 different agents programming at 10 different projects at the same time. And you get overwhelmed because the AI never sort of sleeps. It never says no. It always produces and get back to you. And I'm the bottleneck. I have to answer the questions. Okay, what's the next step? I have to evaluate something. I have to make decisions. And then you can very easily, as a programmer or project lead, become overwhelmed with the possibilities because you can do anything. And then that puts the question back to you, what do you really want to do? You have to make a selection, because it's very easy to sort of run in one direction and make the wrong decision and spend lots of resources, lots of time and tokens developing something that no one wants to use. So you can, there's a risk of running very fast. You can run, I mean, you can still run in the wrong direction, but now you can run much faster in the wrong direction, right? And you get sort of a so making the right decisions and thinking becomes much more important, which is good, because that's what we should worry about.
Mm. Yeah, very. I like it. Running fast in the wrong direction. That's yeah, that's definitely. Anybody wants to add from the panel to what Anders just said? Do you agree with that?
Yeah, maybe one more word about that. I completely agree with this observation that the coding speed and development speed has really increased 100 times, 1,000 times, and nowadays you can use something like Claude Code, for example, or there's also open source alternatives to produce something that maybe a PhD candidate has spent I don't know, half a year or even a year on achieving. And which basically means in that time, while implementing something to demonstrate feasibility of a concept, for example, he or she couldn't be more productive on the scientific side. So it will, of course, also generate in the scientific and in the developer side new turnarounds, but it also means we have to adapt to this. This is also not so easy. And Anders, you mentioned that you are now becoming, or the human is now becoming the bottleneck. I have now also read reports about burnouts of developers because they are so overwhelmed, and the role has completely changed from designing a project and implementing it to more being something like the babysitter for the AI system. And because there are so many people in a company creating code, and then as a supervisor you are bombarded with new developments, and you only have to basically look into this. And as you said, it's sometimes not easy to understand the code that is being produced by AI. So again, that is a bit of an issue. So I believe trustworthiness and also explainability and to make sure that in the end we are not simply believing everything and simply say, okay, I accept, then that will be also a challenge.
Yeah, following up on that, so let's say the accountability, the trustworthiness, the bias that we have in the data is a problem, still is. The LLMs get better, but I'm wondering, Mila, the question goes to you. As you, for example, now suggest AI for evidence-based spatial planning, you use data, you use historical city data, and they are sometimes not correct. There are gaps in participation, there are inequalities. So how do we ensure that AI-empowered evidence does not just reproduce basically those patterns that are wrong or false, actually? So what kind of like workflows and checks would you implement? Thomas suggested already a few, but maybe we can continue there a little bit.
I completely agree with the whole discussion, and it's very challenging. I'm really sharing that it's really hard, because we as teachers here in the university, we are completely aware that our students, our researchers are using AI to produce the code, to produce the systems. But we are really very critical on the results and the simulation, especially on the results, because there are sometimes really ridiculous things are coming out of it. But sometimes they're so close to the real that you hardly can catch the mistake, hardly can catch if there is something wrong. So honestly, I don't have a recipe for this, only being very careful, very critical, and looking at every single code and every single detail in the process of the creation of our result. That is what we do. And indeed, we are turning, our jobs are converting, are changing. We are becoming more of a quality control experts rather than really code generators. It is true. And I must say that this is a problem not only for the digital twin topic that we discussed today, but as a vice dean, I am included in such discussions on a university level for other domains. It's a problem in general, how to use smartly these AI systems in our education and research. There are policies being written now in a university level, but I am doubting until we write the policy, the technology jumps 5 steps ahead. So there are a lot of problems around, and I don't have an answer on that. I'm just sharing that we are all thinking about how smartly to find the answer. So it is challenging, yeah. But maybe serious control in a detailed manner is the answer that we currently perform.
Maybe just one more. Thank you, Mila. I'm completely. Yeah. But one point is basically we have in cities, but we also have for the governments, we have organizations that are controlling and overlooking, for example, the budget that is being spent. I believe in the future we will also need to have AI agents which are really looking at which are really explicitly dedicated to reason about the data that is being produced, the analysis that are being created, in order to make a critical review of these kind of analytics, but also the uncertainties that are in this and the risks that are included in these kind of results that are being produced. I believe this will be for itself a completely separate topic for research. And so if there are people in the room or around in the audience who are looking for a PhD topic, I would basically say even on that questions, you can possibly come up with 5 different PhD questions just on this question.
Anybody taking the bit here? No, let's turn to the audience. We have a few minutes left, so I'd like to open up for questions from the audience, both also online. If there are people online, feel free to ask questions.
Hello, Ranjit Soman from TU Delft, also a visitor in Chalmers. So I wanted to get your perspective on digital twins. So most of what we have discussed today was more about predictions based on the models, simulation models, and how you interact with the models, but also other stuff on digital twins from manufacturing, etc., on continuous learning and how do we improve our practices. So in a simple context, like we have assumptions in the model, but digital twins, you're also collecting the data during the real world simulation, and we could actually test against and modify our models. So we kind of continuously change our assumptions and stuff. So other projects on something similar to that. And also, how does it affect when you think about interdisciplinary models? Like if one model's change, how does it affect other models? So are there some kind of conversations around those kind of things going on within the center or in the wider practice?
Maybe we'll start with you, Anders, and then we'll open up for...
I'm not sure if I fully understand the question. It's quite a broad question, right? To me, it connects to multiphysics. And it connects to models that interact, that are coupled loosely or that are coupled tightly, how one input affects another one. And within mathematics, that's a field. I mean, when you run simulations and you can see what is the influence of one parameter on another system, and you can do complex analysis on that part. So that's something that is being worked on and has been worked on for a long time. Like error propagation, uncertainty quantification, all of that. And that's something that we are, at this stage in the center, we are, the closest Francisca is working on simulations, high performance computing. She certainly does some of that, but that's something we want to bring more into our analysis and simulations. Because it's really important to be able to quantify accuracy, propagate errors, talk about uncertainty quantification of your results. So that's very important. But that's something that we are using in order to run the simulations. But I would say at the center, in terms of software development, we have mainly been focusing on building frameworks and infrastructure in order to make this possible, working with data. But it's sort of coming back to it now because we have the infrastructure to run the simulations. So these things will become more important in the future for us.
May I add something? Because what I also saw in this question, I think the first part was completely, as you said, Anders, that it's the multi-physics simulation, all the linkage of the different kinds of models and the side effects that they possibly have on each other. But when I understand the question, it was also the question, do we have something that is then now looking at people working with the digital twin environment and see how they improve their processes, or how they can possibly maybe if you have used a digital twin maybe in city A and in city B and in city C for certain kind of perspectives, what can we generalize or extract from that? So it principally means, can we also maybe monitor how people are using the digital twin to solve the certain topics, and then create the next higher level of reasoning and coming up with maybe something like common patterns, which are not tied to places or not tied to platforms. And that's, I think this is definitely an interesting question. I personally am not aware of somebody already doing that, but because maybe this is also the reason, because I think we only in the last maybe 2-3 years have achieved this kind of level of system support that, for example, Mila showed really impressive examples. But I believe they mostly have been created also just in the last couple of years, I guess.
Yes, that's true. Yeah. May I add also a bit of answer on this question? Yeah. So for me, the question also related to ontologies. So I completely agree with what Anders and Thomas said, but somehow when the questions was asked, my intuitive answer was, we are doing ontologies for that. And we have published recently a very nice paper. I can put it from our PhD student in the chat. It's related to cross-sectoral digital planning. And there we are mixing the drinking water, urban heat, and housing. So 3 different domains. And we look at 280 indicators. How do these 3 domains and their 280 indicators interfere and influence each other? And it's a very nice paper. And somehow when you were asking a question, for me intuitively that was the answer. So if you want, you can read it. Yeah, I'll put it in the chat.
More questions from the audience? Yes.
Maybe one quick question. It could be a little bit philosophical, but still connected to reality. When we increase complexity of optimization, we also increase computational power. Already today, we discussed that some models, we don't have enough computational capacity, 249 parameters multiplied to city scale, and you will see the problem, how to compute all these things. When we were talking to World Resource Institute Cool City platform, one reason why they do not add CFD model actually is computational limitation. With all this desire for complexity, how we can still keep the level, or how much is enough, where we can inform practice, we can use resources to compute and get results. How to find this balance? What would be your reflection on that?
Do you want someone specific to answer it, or?
Maybe just a short answer for that. I think maybe this is definitely a good question both to Anders and to Mila. But I would simply say it's before we can look at these kind of simplifications, we first have to grasp the real complexity in order to also have, in the end, I would say something like ground truth experience, where we do the calculations in the level of detail with the highest, I would say, most trustworthy models that we have, so that we then can think about how can we make shortcuts, how can we possibly avoid I mean, maybe, of course, we can also avoid some computations to simply say, maybe in order to answer that question, you don't need a CFD analysis. Yeah, so that is maybe the first step to do. But when it comes then to the question, how can possibly we avoid these very expensive CFD simulations, I would say it would be good to have, first of all, a little bit more experience with real data and very good quality data in order to then see, okay, how far can we generalize or create shortcuts?
I think one thing we need is a hierarchy of models. We have like the full model that takes 2 weeks to run. We have something that takes 1 week to run, something that takes a day, something that takes 10 minutes, one thing that takes like 10 seconds. So you can do surrogate modeling, you can do simplified models, and you can quantify the performance or accuracy of one model by comparing it to the more advanced model. So you have, at the end, you have the full CFD that takes, take 2 weeks, or takes infinite time if you want to get really high accuracy. So that's one answer, to have a hierarchy of validated models, and you can always go to the more advanced model if you want a more accurate result. And then you have validation, of course, to experiments that you have to do all the time when you do simulations. Another sort of comment on this is that this is great news for those of us in numerical analysis and high performance computing and scientific computing in general, that there is the demand for running faster simulations, because that's the motivation for every single paper that we write. Here's a new method for solving the Navier-Stokes equations that is 10% faster or 10% more accurate than the previous one. So that's great news for us working on those topics.
Thank you, Anders. I'm going to push for some more questions here from the audience, and I saw that you, Christina, raised your hand, so I'm going to walk to you.
And I'm going to challenge Anders here a little bit, because what we've seen is that we are democratizing intelligence. We saw that the huge LLM models all comes from commercial companies. I haven't seen very many in the same scale coming from the universities. We know that these companies attract the smartest people, at least some of the smartest people, I should say. Apologies to you all. And they are also very interested in numerical modeling, and they have probably more resources than the universities have. Do you think, and this is like more of a philosophy question, do you think that the universities striving for excellence will work more on trying to explain things happening that have little commercial values?
We can't hear you.
Sorry. So I think this will actually be even more profound change, in that more and more research and more results will come out of the big labs, the commercial labs. So Google will be doing all the mathematics in the world. Or OpenAI, or whoever does that. If I go to my own field, there's a very intense debate now in mathematics, with more and more results coming out in mathematics, which is a very clearly defined subject area, which can be formalized. So it's like a perfect place for an AI to be and come up with all the new theorems and proofs. So there is a really sort of big debate going on as to whether universities will actually be able to compete, because the one with the biggest machines and the biggest model will be able to solve the hardest problems. And I think that that's something we cannot avoid. Yeah. And probably, I wrote this in an internal debate yesterday at the department, like an email thread. Where will we be going? Will we be obsolete? And probably yes, in some years, because mathematics and probably other subjects will go the way of chess. It would be like, it's fun to watch. You can have people who are good at solving mathematical problems, but it would be like a competition. The real foundational work, the progress will be made by the ones with the biggest machines. So I think that's unavoidable. But it will be a slow change. It will be a slow change, because universities are slow to change, and we will adapt in the meantime to some extent. But it will be a profound change in how we do science. So that's like a philosophical answer to a philosophical question, I guess.
I would at least ask the question here on this answer. I mean, the large language models are really synthesizing from what they know before. However, there are some limitations to the creativity of and that is the question: when will this break? Maybe there will be sometime in the future when this breaks. But that is at the moment, I would see something like a natural barrier to also the general, what is this, the general intelligence that should be achieved by AI systems, or that should be, that people are looking after to achieve, which of course is can be a risky thing in the end. I would like to add maybe one more thing is, what you see currently in the development of these large language models, or generally is about these multimodal models, is nowadays when you want to have when you talk with a large language model, so using natural speech, first of all you have a model that makes speech recognition, translates that into text. Then the large language model working on text is producing an answer, and then you are using something like text to speech again, which is another neural network. Now, this is merging, and basically nowadays they are coming AI models where basically directly the speech is going into the model. There is no more tokenization in regard to syllables or text, and they are directly producing speech again. So that means the reasoning and what is basically going on is no longer visible or accessible, and these are quite powerful and quite fast. Maybe our brain is working in a similar way, but I believe that maybe also in the future, if we have something like special domains, special problems like computational fluid dynamics simulation, maybe in the future we will even see AI being trained in such a way that you directly feed in the problem, and however they are not really segmenting it anymore somehow, but directly coming out with an answer, where however it might be difficult to verify or to understand how this has been created.
And maybe I can add that. Add something at the other end. I mean, you said, I mean, speech goes in without being tokenized. In the other end, I mean, now typically the output is Python code, but there's also development where the output is bits, so you never see the code. So you go directly to machine code from the generation. So I mean, it sort of removes all possibilities of human understanding from the loop.
Very short one.
So I would like to challenge you back with one point. Yesterday I was talking to head of Airbus Foundation, who investing a lot into science museums. And I asked, what is your main core motivation and area? And he said, the truth. We need teachers and academia stay for truth, because even if they can process data, and as Anders said, it's fast, but what is direction? And I think in this case, I do believe that the role of academia will remain to work for the truth and to work on the right direction, where all these supercomputers direct in the the knowledge. So in this case, I would try to protect a bit academic side, that it is a big need for evidence and truth, which is not always guaranteed by these big companies. They can do it fast, but are they doing it right direction?
Yes, I've got one last question for you, Eric, actually. So in the digital twin domain, we claim that we contribute to creating more sustainable cities, which I think we do. What now with large language models, extremely data hungry, power hungry? Are we running the danger of actually offsetting what we actually can aim to do here, being more sustainable?
Yeah, thanks for the last word. I think here on the topics that's most interesting, how we can use AI for creating sustainable cities with help of digital twins. And of course, we need to have data to build the AI models on, and that's our main scope within our city. In our new policy, we are looking at the data as a strategic resource, and we have to open up the silos for that kind of analysis, AI analysis. But I also want to say that Mila talked about this multidisciplinary approach. The city is so complex and we have different dimensions and there's a lot of conflicts. And if we could use AI for solving those conflicts and plan a more sustainable, livable, happy city for everyone, so that would be the perfect aim for using AI in digital twins. Thank you.
Yeah, Anders, you want to add to it?
Let me just say, I mean, something I'm thinking about here in relation to your question is that I don't think sustainability is necessarily about using less energy. So I think if we use more AI, we need more energy. So we should use more energy, strive to use more energy in a sustainable way. There's plenty of energy to go around. So using more AI, we can produce better societies. And if we have to use more energy to do that, I don't think that's a problem.
Okay, I think that could be a longer discussion, actually. Not sure I fully agree here, but anyways, I want to thank you very much for participating in this panel. It was a very interesting discussion. We will now break for lunch, and we will be back here by 1 o'clock with 2 more keynotes. But before that, we'll also have a speed round looking into our projects, which I'm very much looking forward, and that's for you as the partners maybe most interesting to see where we actually are right now in our projects. So once again, a big round of applause for our podium here, and see you back.
See you later.
See you later, yes.
Welcome back, everybody. Hope you had a good lunch and some good discussions. Yeah, so this morning was about, I would say some more overarching visions and AI trends. And I thought it was very, very interesting. But now we want to get a little bit more hands-on and showcase a little bit what we do currently at DTCC. So we're going to have now a presentation, or several presentations, of the projects that we currently run at DTCC. You see them here listed. It's not going to be that order, but this is an overview. And I think we're going to do it like this. We're going to have 5-minute presentations, and I'm asking you as the people presenting now really to stick to the 5 minutes. And then at the end, we will take questions. I think that's the most effective way. So in total, we have an hour now, and I hope the time will be enough for this. And I think we're going to start with Oversight, a project that is led by Matthias. But Ahmed, I think you will present this time. And Ahmed is the PhD that has started when?
9 months ago.
9 months ago. So the stage is yours. Welcome, Ahmed.
Thank you. Hello, everyone. My name is Arif Yakpulder. I am a PhD student working within Oversight project. And I'd like to give some information about what happened since the last time that I was presenting the project. So basically, this is going to sound obscure in the start, but it will make sense in a bit. GEMS became operational. GEMS is our AI that can detect construction safety hazards from images or given videos. And currently, we are about to publish a paper. And as you can see from the image as well, that's somewhat how it detects issues. Also, we managed to create a photorealistic reconstruction of a partner site from a capture that we have made. And also, we have managed to align it with the BIM model that is for the same area. So it was, yeah. So it was a quite long last 3 months, so to speak. Anyway, so I need to now roll back to GEMS. Basically, we started from data given by Bixrinen from their checklists for the Lumi construction site. And we have worked with 649 construction safety issues for that given site. All of them had images attached to it, and the site managers also wrote descriptions of the issues that were given. So we basically run our AI on the images and asked it to find the safety issues. On the focal imagery, so like on the image that was embedded within the issue, we had 87% accuracy on detecting issues. while we had 11% overshot positive, meaning that the issue was found correctly, but it also hallucinated one additional issue. When it comes to 360 imagery, we also then randomly selected a couple more issues to go and find in the 360 sidewalk of the same area. So we would be able to go like, okay, can we actually use the sidewalks for the same idea as well? And within that, we managed to get around 56% positive rate, while having around 10%-ish overshot positive. This drop was due to AI bias, where it's basically the data sets are trained with intentional images. So when you are taking an image of something, you basically have the intention of positing that thing in the center of the image. So because of these not being existing in 360 imagery, we had a drop down in the correctness rate. But on the contrary, being able to even a falsely flagged issue can be used to a benefit, because technically it's always, better safe than sorry in these sort of scenarios. And the way that we're planning to go forward with this is that because we do now have the photorealistic reconstructions as well, this is a dollhouse sort of view of the area that we scanned. We can technically make our AI create 3D spatial markers where it, for instance, detects trip hazard, detect the junk left on the floor, and then automatically assign this to a worker on site to clean up the issue, and then also automatically recheck it back from imagery, maybe captured that night, to reconfirm that the issue is resolved. And also we are aiming to take this layer a slightly bit more forward when it comes to basically creating this layer of AI translation on issue writing. Because a lot of the issues written by site managers, written by inspectors, they were, to put it simply, they are not descriptive. It made it almost impossible to be able to compare the AI's results to human results, as the human results were literally an image and says, fix this, please. And that's, for a worker who's picking it up, is not descriptive enough. So if we can posit our AI also as an assistant to write these issues, we can bookkeep better, and also we can decrease the friction that is being generated from miscommunication. And as you can see, that's how our AI creates an output. It gives a JSON output. And this output can be directly converted into a BCF issue. So we can technically create those markers that you see over there. That's a safety issue from the fly. And when someone is using Oversight as an application, they will have the chance to be able to see it in the virtual realm of it. And this has the potential to carry the project from being a digital shadow with cool representations into an actual digital twin, as it can create and basically modify tasks that are affecting the real world. So thanks so much.
Yeah, then next up we have not Margojata, but also your PhD is going to present. Your name isn't even on here, but you can introduce yourself.
So, hi, I'm Yowei, and so I'm working in this digital twins for architecture reuse project, and then Margojata is my supervisor, and also I have a co-supervisor, Alex, which is helping me on the sustainable part of the project. And we are working with Ellen and Fanny from Lilleball, and then also Jakub from Stina. Yeah. So this project, we're focusing on a smaller scale on digital twins informing design and fabrication workflows to accommodate the variability of reclaimed materials while maintaining the manufacturability and machine processes, ensuring the performance of the built structure. So usually when we are building with standard materials, we can use very easily to industrialize it and also make it bigger, and then with the robot to scale up the whole building process. But then with reclaimed materials, they have different properties. They have their twisting, they have their weather conditionings, their different geometry and sizes, and also broken parts when you get it. So then it becomes hard to really automate the whole construction process. But then to do this, we have to kind of accommodate to the variability of these materials. And then what we're doing is we're using a robot, and then we're getting all the data from the digital twins from the material, and then we're deciding how to fabricate the material. Then we can automate the whole process, and then build a structure inside a new building. So we're kind of planning is we have a building stock model, and then we're trying to plan the whole process from getting the materials to scanning it to getting other properties of the material, and then how do we manufacture these materials that we can build it into a new construction element that we can use inside our buildings. And and then what we're trying to get from the digital twin is all these different types of data, even also with the robotic data, the material data, and then material placed in the robotic fabrication process where the data is, what the data is, and then looking through these whole process of how we design reclaimed materials using automated manufacturing. And then what so we're thinking also like in later parts of the project that we can introduce these agentic AI things into the whole process. Like for different workflows, we have different processes on optimization. We have different processes on robotic fabrication. We also have different processes from the design part. And then how can we introduce these agentic AIs into automating the whole design process of fabricating a new building element with the reclaimed material. Yeah.
That was under 5 minutes. Wow. You're going to get some extra questions then. Or Alex will use your time now when he's presenting mixed realities.
Great. Great to be here. I'm Alexander Holberg. I am the project lead for this project, but more important is actually Jiming, who was here earlier but had to leave, unfortunately, who is the PhD student in the project and driving the research. And we have two co-supervisors, Sanjay and Liane, and we're thankful for all the partners supporting this project. So what is it about? Well, the main question is how can mixed reality support design and decision-making processes towards sustainable cities? And how to define mixed realities can ask different people, and you will get lots of different answers. The way we use it is basically using 3 components. So you have some augmented reality device. We're using iPads now in this case, but you can also imagine having goggles or just using your phone. We have some simulation results, could be also real data, as Elena said before, but something to visualize, and what we call a physical clay model. So we usually work on the building or the urban scale. So we have it, this can be 1 to 1000 model, but you could also use it in 1-to-1 if you use, for example, on the construction site to show the hazardous problems in your goggles. But we use this type of mixed reality that, let's see if I can restart this video, that if you combine those 3 technologies, you can imagine having a model on the table and having your iPad and visualizing additional virtual information on top of the real information. Now, this technology is not something new. We just make it work for our use case, but we're more interested in this question, how does this actually help? And then we came to this question earlier, who is the end users? And we have different end users in mind. And the first study was, how can this mixed reality or augmented reality support building for performance simulation learning? And we did an A/B test with architecture students. So they got the design task to optimize a building, lower the energy consumption while keeping a certain level of daylight. And that's not the most complex task, but it's also not trivial, meaning there are lots of different parameter combinations. So they got the test. We had the group A testing this on the iPad and the AR tool, and a group B using a conventional desktop Grasshopper overview. And we compared the outcomes, or that's what Jiming did. And we will present his first results in Singapore end of the year. And what we see by the results is basically that we don't see a huge benefit or big difference in the performance outcomes. So meaning the results that from the optimization isn't better using the AR, but students were much quicker in generating design alternatives, which was 30% reduction time compared to the desktop. Now, this is only a first study and we had 24 students, but it was nice to see that we get some clear difference or statistically significant difference in some parameters that we looked at, but for others we couldn't tell a difference from this study. Now, we don't only want to work with students, we also want to work in the real world environment and practice. So the idea is to have this matrix of using 3 dimensions from the first room scale to the building and then the neighborhood scale, and use also different types of users. So experts, which could be architects, sustainability consultants, or also citizens who are interested in participatory planning. And as I said, we can use different devices. So far, we explored a lot the iPads and a visualization with a projector on top. And this is a short glimpse to our mixed reality studio that we have now as a test case at our ACE office at Chalmers. And there's a very nice YouTube video. Now, I didn't want to go over time and show this, but you can scan the QR code and see us explaining, but more importantly, Ida, who is responsible for the campus development from Chalmers Fastigheter, for how should the campus of Chalmers develop in the 20 years, and her opinions of how this could be used to inform then decision making. Yes, thank you.
Yeah, next up we have Franziska. We're still doing well in time.
Thank you. So I'm Franziska Hunger, and now I'm presenting our work on the urban trees. And I'm very pleased that Mila already presented those very great examples of multimodal simulations and multifunctional analysis, because that's also the road that we are taking here. And I'm also very happy about the discussion if physics-based simulations are still very relevant, which left us hopefully all with the idea that it is still relevant. So the track that we are taking here is similar as for the pure urban simulations, but here with the focus on the urban vegetation. So we combine those different steps of the data acquisition, then creating the 3D model out of that, running physics-based simulations, running analysis and assessment, and supporting the decision support. And what also has been discussed already is this uncertainty and the level of detail of the input data, of the available sensor data, and then also the level of detail on the urban models and the tree models that are input to the analysis, obviously, and also input to the physics-based simulations. So when we look a little bit into detail into the data integration, you know that there are very many different sources of data available for the urban vegetation, and they come with very different characteristics, very different resolutions, and very different levels of detail. And from all of them, we can create some kind of 3D representation and some kind of simulation input model. And that is a question that we are looking into. What, in both ways, so to say, starting from the accuracy that we have in the input data, what can we expect for the accuracy in the simulation results, but also the other way around, depending on the question that I have that I want to answer, what uncertainty or what level of detail can I accept for the input data. And then here's just an example of a simulation that we have performed. So we're looking at those different tracks for urban planning on the one hand side, but also urban maintenance on the other hand side. And they come, of course, with different questions and different requirements. So here we are exploring how to use the simulations in quantifying the results that are actually applicable for their for those different groups. So here on the right-hand side, for example, on both sides, we did a pruning study where we just really look into detail what happens to the loading of the tree when we prune a tree in different ways. And on the right-hand side, we did the district scale simulation, looking at what happens to the remaining trees if some of the large trees are removed, so that the maintenance, the tree maintenance, get an understanding on where are the effects the largest, which trees are affected the most when I remove several large trees, or which need, or if trees fall down, for example. And then with those simulations and the analysis, of course, the aim is to support evidence-based decision. And as I said, we have those different tracks that we look at the tree, or that we work together with the urban tree planners, where we, for example, can identify critical areas or assess alternative tree placements. Then also what was shown with the pruning study, for example, to look at risk and maintenance prioritization by quantifying the forces on the trees, and consider different maintenance scenarios. And all of this then coupled to the DTCC platform, for example, should be integrated in a GIS or a digital twin. And then also exploring together with Alexander and his group different kinds of visualization. Yes.
Yeah, next up we have Dag Westberg to talk about AI digital twin.
Right, so we can talk about what we're calling AI first digital twins. This is, sorry, this one. Exactly. So, and this is like using AI. We're talking like how can AI be used to build better digital twins, and AI used as the primary driver for creating digital twins. Current digital twins, they're snapshots of point in time. They're made up of copies of the data that's available in time, like often through a ETL pipeline that takes it. They take all the data they can find, and then they just shove it into and try to create an artifact, not created for a specific goal, but it's like generic models, hopefully that can solve all the problems that we may have or want to have answered with a digital twin. So the thing is, like, can we now, the goal is here to look at, can we make the digital twin the output from an AI agent query rather than a data warehouse in itself? So the idea here is that the agent it'll be able to compose digital twins on demand from data sources, both local and remote, so that the data itself stays, or the raw data, as it were, lives where it lives, and it's accessible via APIs or other calls. Because this way and then the data then, and then the AI model, it selects and assembles the model or the twin based on what you are asking of the model. And also this way that the AI model will then be able to like take this raw data and enhance it, modify it, enrich it as it builds the model, so that your output is it's created from the latest data sources. The data is grabbed as you create the model. It is built to solve your problem, and it is modified and enhanced specifically to facilitate solving that problem. And also this allows, as you add new data sources, these data sources then become discoverable by the AI agent at build time. So if there's a new data source added, so if you by data space or something similar, when you then call the AI agent to create a digital twin, it will then be able to like look through all the data models it knows about and pick the ones that it thinks is the best for this problem. So this allows the model always to be fresh, or at least as fresh as your raw data. Data privacy and access control is controlled by the data owners because they are the ones that decide what the AI agent, what each particular AI agent from each particular user can and cannot do. We're also like, and this makes everything, as I mentioned earlier, everything is composable and discoverable. New data sources get added, it can find them, and it can include them into the model. You don't have to re-architect the digital twin. The AI agent can do that. It's like also like we had Anders and Lilival mentioned, like, okay, what happens when the API changes? The AI agent will. The idea is like Anders mentioned, the AI agent can solve that because the AI agent can read the documentation of the API. So the AI agent will know not only how to access the data, but what data is there. And then, so you don't have to do this. Also looking at, and the AI agent can then also, if you want, when reading the data, apply, it can do change detection, it can do anomaly detection on the fly during model creation. So that not only does it just read the data, but it can also compare the data to other data it's seen to see if it looks reasonable, to see if it's changed, and do like, and all of this will hopefully, the plan is then that all of this can be done on the fly during model creation. However, we don't want to just let the AI agents run wild. We're not vibe coding a digital twin. We need everything. It's important that, especially if this can be used for decision making, we need audible and verifiable digital twins. And so this means that it's important that we have audit logs for data access. And when the AI builds the model, after it's collected the data, it needs to do it using recipes that it get logged. So the idea is that it's not just grabbing a bunch of ad hoc data and trying to join it together in ad hoc ways. It is grabbing data and it's using recipes that are, or data sets, data models, algorithms that are robust and verified by the developer. So the idea is that it's not building the simulation model on the fly. For example, if you're asking for a simulation, it is collecting the data needed to run the simulation, but the simulation is verified and trustworthy. So we're not vibe coding. The idea is not to vibe code the simulation on the fly. And to make this work, the other aspect is also that, like, to be able to get like reproducibility, it's not enough just to have the recipes. We also have to have, like, the data stores must be versioned. Because, for example, if you are, say, you build a digital twin to run a wind simulation, and then you can have the recipe exactly how you did that. But if you cannot access the same data you used, like, for example, if you said, okay, if your recipe is like, okay, grab the latest data from Lantmäteriet, build a model, run a wind simulation. If you run that 6 months later, you won't necessarily get the same data. So how do you handle, so that's also looking at, like, how can data stores be versioned to manage to get back to where we were. But the core idea that we are looking at here is that the digital twin will be composed, and it's not stored, and it's delivered fresh, and it's designed to fit the need. And the AI agents will here be the tool that we use to collect the data, to compose the data, and to build the data to make a fresh digital twin specifically designed for the need of the user. Thank you.
So I think we have all quite good on time, right? Yeah. So I will talk about 2 projects here. One is AI 3D city modeling. This is about developing methods based on AI or neural nets, and also computational geometry, in order to create highly accurate, high fidelity 3D models of cities based on raw data. So the idea here is to combine all possible data we can get our hands on to try to sort of push the limit here of what kinds of geometries we can generate. And it's not just about generating these geometries and building tools, it's also about investigating the methods and developing guaranteed accuracy for these methods. So we can say that based on this data, we can provably generate geometries with certain that satisfy certain constraints with prescribed accuracy. So trying to push the boundary here of what kinds of geometries we can generate from raw data, and trying to compete with state of the art in terms of generating these 3D city models. And this will be implemented as open source components in DTCC platform. And we have a new student coming in September to work with this together with us. So this starts in September 1st. We have our student Florian coming from TU Berlin to work with us. We had a recruitment process going on with 100 applicants, and he is a great candidate to work with us on this project. In the meantime, we have been working on this project already for more than 1 year. So what we can do currently is that we can generate high quality 2D representations in LOD1 for like all of Sweden or whatever region you pick. We can generate 3D volume meshes also of high quality for any region you pick. So it's still limited to LOD1, so flat roofs. That's based on both limitations in our current technology pipeline, but also limitations in terms of the data that we can access from Lantmäteriet, because they have quite sparse resolution in terms of point cloud. We have done some initial work, so we have semi-working or working in a prototype LOD2, so we have the roof shapes as well, so we can do that. But the goal here is to push beyond LOD2 and generate these data sets automatically with high quality and very efficiently. So if you haven't tried that already, you can actually go in and you can use our tools to mark any region in Sweden, and you can press a button and then you get the 3D geometry in any way you like. We work with point clouds, we work with street view images, aerial images. So anything, we want to combine these and take the best from all of these sources, combine the parts to get something that is bigger than the parts to generate high quality models. And then there are requirements that you can expect. You can talk about accuracy, you can measure that, you can speak about topological correctness, having volumes that are watertight and so on. In some cases, this is not important, you just want to look at the geometry. But in other cases, if you don't have a watertight geometry, whatever you try to simulate or analyze, it will break down and crash. Not give you like a wrong result, but just crash your computer completely. So you have to make sure that the geometries that you work on, they actually satisfy certain constraints. And this is now making it possible for us we talked about this having worked on infrastructure for a few years. So in terms of simulations, we can now go back to something that we wanted to do a few years back, which is to run different kinds of physics-based simulations on these city models. And to do that, you require to have a model, a mesh. You need to have some kind of representation of your city, and it needs to satisfy certain requirements. So we had 2 master students now working in the spring here. This is Marina, who has been working on solving the Helmholtz equation, which is a model for noise propagation and other things. You can use it for electromagnetic waves or antennas, stuff like that. And this is Avenyn in Gothenburg. If you can go in here, right? The Avenyn Götaplatsen. So what she did, she just sort of found the coordinates for Poseidon and she said, okay, let's take a 500 by 500 meter square meter area here and press a button and run a simulation. So this shows isosurfaces for the Helmholtz solution. We don't need to discuss sort of what that means here in terms of modeling, but it signifies that the solution to this problem is a quite complex solution. It has a lot of structure, which means it requires a lot of resolution, a lot of computational resources And the challenge with this problem is that it's actually quite hard to solve. If you go to realistic frequencies for noise modeling in a city, it turns out that to solve these equations, even though, I mean, not just sort of keeping them in memory and resolving these waves, it's actually quite hard to get this to converge. So what she has been studying is new efficient methods for preconditioning these simulations or the solvers in order to actually be able to solve. So it's a problem. It not only takes a very long time for it to converge, it actually doesn't converge. You never get the solution. But with this new method, you actually get the solution, and you can do this with the press of a button for any region in Sweden, if it's reasonably moderately sized. So another master student, Cecilia, has also been doing a great job here with looking at the flood simulations, solving the shallow water equations. So will it start here? Yes, it starts. Yep. So this is also another like toy problem where this has no real world significance in terms of solving some actual boundary conditions or some actual flood waves. But this is again the same domain in Gothenburg and demonstrating how when you can generate these geometries at the press of a button, you can basically simulate anything. So we're now building up the capabilities here to have a collection, little zoo of simulators, and then of course we will be working with our partners in order to find real world cases and put this to the test and validate these simulators. But now it's about building up the capability here in terms of infrastructure to make this possible. And this is then becoming part of DTCC platform, which is another project which is ongoing. And the way we see this is that we wanted to be able to make it possible to discover and inspect urban data and be able to, at the press of a button, build analysis-ready digital twins. So the vision here is to be able to say, okay, I want to make a digital twin for my city or my region. So then you basically just point on a map and say, here's where I want it. And you mark this region. And then depending on how big it is, it takes less or more time to generate it. And then when it's done, you have it there and you have all the data sets and it's up and running. So that's basically the idea here, to be able to, at the press of a button, generate something that is a digital twin live of that region. And to do that, one part of that is to make data sets available. So we're working on making basically any data set available. Any does not mean all, because I mean, that would be like 1 million. But we are constantly adding new data sets in order to strengthen the case of, say, I can have any data set in my digital twin. We have to have a larger number to demonstrate that we are somehow able to deal with many and diverse data sets. So currently we have in our little prototype, we have 14 raw data sets. And these are data sets in the same way as that Dog discussed here. They are coming not from us, but they are not stored with us, but they are coming through different APIs. And we're trying to expand this. So whenever you say, give me a data set for this region, we get it from the provider. And we constantly need to keep up with the APIs and the changes. That happens not all the time, but they happen frequently enough that it's a problem if you don't have AI agents that run around and fix this for you. And then we have this composability that Dog also talked about. If you have raw data sets, you can combine these into new data sets. So one example is combining some of these raw data sets like point clouds and cadastral data, street view images. You can combine those and then you can compute what becomes a new data set, which then can be a 3D city geometry of different resolutions. So all these data sets are in some set parameterized. You can say, I want to have a 3D model of this region with these requirements. I want this resolution, I want this level of detail, and I want it in this format. So everything here is something that doesn't exist. It's a potential thing that you can generate. And then we have these derived data sets, for example, the 3D geometries. You can take those, you can combine those. Maybe you look at wind simulation or air quality simulation, and you combine maybe the 3D geometry with another data set, which can be wind direction, wind speed, coming from sensor data to create a simulation data set. And that's also something that exists sort of on the fly, potential data set. You press a button and you say, I want to run a wind simulation for which region, using which properties, what resolution, what are your computational resources in terms of resolution of that simulation and so on. And then I want to have this data set in maybe in CityGML, or you want it in GeoJSON, you want it as an image, you want it as a video. That's something that you can control. And then you can also control where you want to look at this. So maybe you want to look at it through some VR glasses, you might want to look at it on the web, you want to look at it, want to create a nice video for presentation, or you want to view it on the 3D table that we are building. So that's the idea with what we're building. So this has, I mean, this looks very much like what Mila discussed before. So you have the data, you have something, the core here, which is the thing responsible for representing the data, sending it back and forth. You have different analysis engines, you get curated data sets, and then you can experience those things on different surfaces. So some kind of layering of these functionalities. Very much like, and you can discuss like if is it 3 layers or 4 layers or 5 or 10 layers, but it's definitely something coming from raw data towards some experience where you do a lot of data processing and simulations in between. So our current focus now, I think this is my last slide here, is building this catalog of curated data sets. So we want to be able to publish these data sets and say this is a data set for wind or air quality or 3D geometry with a certain property, and being able to say this has been validated, this has a certain level of quality. That's not the case currently, but that's what we are working towards. Now we are currently more sort of expanding our data sets, creating more and more. And we have something called, I mean, these are temporary names, but we think about them as DTCC Atlas, which is this part here, which is a web interface that allows you to explore this catalog of data sets, create new parameterized data sets, and press buttons to run simulators to create new data sets. And when you have created a data set, you can bookmark it, you can share it with someone, you can come back and look at it later, and you can also publish this data set to our 3D table. So Alexander showed this 3D table that he has created with his group, and we are building on that experience and creating a new 3D table at the math department. So we have can play with it a bit more. So we are now setting up, we have set up this little mini lab where we are now 3D printing these tiles. And the idea is that whatever data you have, is it raw data, is it derived data, is it a simulation, whatever it is, that's something you can at the press of a button experience on this 3D table. And we're also striving to make this setup of creating these 3D tables open source and automatic, so that you can say basically you can go in and mark a region on the map and say I want this region, so you press go or run or generate, and then you get a physical digital twin of that region. So it actually comes out on the printer. And maybe you have to assemble it by yourself and put it on the table and put up the projector, but we are trying to make this as simple as possible. Even sort of the projection, I mean, how to set up the projector, that is quite mobile. So you can sort of put it in a bag on your back and carry it to an exhibition if you want to do that. So what we want to do now is during the fall, focus a lot on working with our partners, the municipalities, to talk about which data sets do you have, how can we incorporate that into what we are building, what questions do you want to ask the digital twin, so we can test out that this is actually working. So finding these use cases. And we have been working during the spring on this, already started with our 2 interns, Amar and Nouri, who are here today. They've done a great job talking to our partners and exploring what needs they have. And they have also been great in working with us setting up this lab. So we will continue this process during the fall to get much further. And I'm talking about these TRL levels. We want to really climb here and create something that is really useful as an end product, but at the same time be based in all the work we're doing on science-based generation of 3D models and simulation results. And also trying to adapt and be able to accommodate all kinds of diverse data sets that we can really get our hands on. I think that's the last one, right? Yes.
Yeah, I think what we'll do is everybody come on stage who just presented, and then we'll just take questions. Can we move the camera so that, is that easy or not? I don't know. Can we move the camera a little bit so that, aha, can you maybe read them out? Ah, yeah. Yeah, then we didn't have a question from our online audience yet, so whoever has a question online, please feel free to ask.
Yeah,
I think we were able to hear you.
Okay, so my question is, there was one presentation about using recipes, and I recently learned that city of Rotterdam is also going in that direction. Is there, have you already developed the framework behind it? Because I also believe that this kind of idea is leading in the right direction. On the other side, you mentioned also that the problem will be that the recipe may be working with the very specific configuration of data sets and place where you are, but maybe not 100% transferable to somewhere else. So have you thought about maybe using something like a two-level recipe? So one which is rather platform independent and city independent, and a second one which then is more tailored to the specific situation?
Yes, I mean, we haven't started like first of all, I haven't started formalizing the recipe like format now. It's so that would be interesting if there is like a better way to do that now. It's kind of more of an ad hoc kind of collection, and then it's like using the tool calling aspects of the LLMs to try to organize them, and then I just and then you log just like a JSON file or whatever, like what it did. As to the data aspect, no, I haven't started looking into exactly how to do that, but that is a valid point, that like the data does need to be data coming from different sources does need to be normalized in some way for the recipes to work. So that is like it is like kind of a two-step process. One is to like collect the data, normalizing it into a data class or some sort of data schema or set of data classes. And then once you have normalized it, then you can run the recipes and get the output, and then take the output, and yeah.
Maybe you don't need to really normalize the data, because you can have a recipe that is pretty much tailored exactly to the current situation that you have in a specific city. But however, as I said, maybe just a higher level recipe could be then more abstract, which is then basically something like when you're using agentic coding, you can also ask first to make a plan. So something like this would be a plan level, and then the second thing would be then more the execution.
Yeah, no, that's definitely that's absolutely an approach. It's worth considering. Yeah.
So yeah, there it is. So how would you relate this talk about recipes or workflows to the concept of skills that are in agentic coding now?
They're similar. I think that the goal was to kind of the recipe approach is that I want the output to be reproducible. Like, I mean, with skills, if you run the same thing twice, you will not necessarily get the same result. And also with skills, you have more, or the LLM does have more flexibility to go off and do what it wants. So the idea was the recipe approach is that and the tool-based approach is that it should be more limited in what it can do. and that like once it has done it, it will create a log of what it has done in a way that makes it easier to do exactly the same thing again, without necessarily the LLM having to get involved.
Okay, thank you.
This is a question for you, Francesca. I really enjoyed your presentation about the trees, and you talked about effects of trees being cut down. Are you also simulating effects of planting new trees to like find the perfect place where your trees are needed?
I mean, that is what we are looking into, the scenario analysis, where are the trees and have the biggest benefits. So yes, I mean, in our kinds of simulations, you're very flexible in putting in different kinds of trees, but those scenario analysis come down again to what do you know about the trees that are going to be planted? Do you know what the shape should be in 20 years' time, or what you're aiming for, and what species it is, and how dense it should be? Yes.
I think that could also be interesting to, if you want to create green corridors for the insects and so on, that could be interesting to like have the tool to recommend for you where you really should reserve spaces for trees. Maybe.
Yes, that's also a very good point. And Meta and her group has looked into the biodiversity and did a study, but on birds, and connected that to trees as well. So we have talked a little bit how we can connect this, because that's coming back again to this multifunctional approach. There are so many things, and sometimes it's also contradictory. So for example, the air quality, you might have some situations where you actually trap the pollutants, while of course you have the shadowing effect. So you have to balance that or prioritize.
Yeah, I think that's very interesting to have like information for decision making in the city. I think that would be very great to have as a tool. Thank you.
That's what we're aiming for.
Sorry if I'm asking too many questions. Just very interesting discussion. I have a question actually to Alexander with your mixed reality studio. I think you managed to really unify all Department of Architecture around this table. So it was really great experiment to invite different like researchers around one artifact, and then also industrial partners. Now I also know the plans is to test things at Universium, so we work with their team. What is like ultimate goal and impact you see this type of tangible interfaces could create from a bit broader than just academic perspective?
Good question, long answer. Maybe I can answer in two things. One is the aim of our project, which is to explore this question, how does this actually help? I mean, it's fascinating, it's cool to see it, but does it really help to make a decision process? So there we use these methods to try to analyze how the decision-making process and find an answer to this. But I think the side effect, what you're into now, is that this really sparked a lot of interest, and it's a great way to collaborate. And maybe because it's very simple, it's easy to set up. The first version was just a PowerPoint projected from the ceiling, and you show some stuff, whatever it is, some visualizations, but you can stand around and talk about this result, and you don't need goggles, you don't need to be immersed in some virtual world. You can just easily use this, and that's what makes it scalable. And now you mentioned Universium, we had other interest from partners, so we're now happy that this is an option to explore this further with Chalmers Next Lab. But also Eric just said, yeah, maybe we can use this for a new model they're developing. Anders mentioned the model at the math department, so I think it's good to explore this in different ways and have it as a facilitator to collaborate. And also talked with Ranjit about this way of it becomes a boundary object so people can relate to, and it facilitates collaboration across disciplines and maybe people who might be lost in this digital world on those terms they can still be involved in the process.
Okay, no. Alexander, yeah, really great stuff. I also been talking about boundary spanning objects for 5 years, so it's really great to see that. And also your question, or what did you say, like, would it help? Right, I love that. So it's more of a, great work than anything else. For Per, I actually had a question, and also for Anders. So for Per, you said the AI, like multiple times. What does that mean? I mean, LLMs, in that case, what kind of LLM? And are you using, Terminal, or using ChatGPT or Claude, or what are you using?
Well, the LLM now we are testing. There are two aspects. Well, first of all, it's building around currently it's LLM and tool calling, the tool calling aspects of the LLM.
Which LLM?
I'm using Claude. No, I'm using Anthropic. I'm using Opus and Sonnet mostly.
Okay.
But it's an implementation detail really, because I am also at the same time working. The goal is I'm comparing that to, or I will be. I'm sorry, but the point is also comparing that to local LLM models, because the problem, or the fact is that for many cases, using kind of a third party and especially US-based models is not an option. So we are comparing what Anthropic models, the state-of-the-art Anthropic models can do, to what the open weight models that can run on a reasonably priced machines can do.
But just a question: why you're not comparing also to, let's say, Gemini or to Codex or any of the other ones as well? Because it's fairly easy to just
No, I mean, I have a little bit, but it's not really. I've compared it to like the OpenAI models, and it doesn't make big enough difference that it is interesting to focus on that right now. I find that the interesting difference is between the kind of the large state-of-the-art kind of external models versus a local model.
Okay.
That's the interesting question, I find.
Awesome. Anders, just a quick one. We talked in the break about a lot of different things. We don't need to repeat that maybe here. It was the telecom side.
Yes.
Because I thought that was super interesting, what you've done with the mathematical simulations. Would that also be, well, let's rephrase that. How would I be able to use that from a 5G 6G perspective and simulate RF spectrums with the pipeline, right? Because it's the same sort of data set, and more in not necessarily answering the question from a telecom perspective, but as more of a pipeline. How would I engage and actually use this with a partner?
Yeah, I mean, what you have now is like a generic simulator for anything that is wave based, which can be sound, it could be light, it could be electromagnetic signals for 6G, whatever it is.
Yeah.
But what we need to add is the domain expertise. So I mean, if you just press a button here, I mean, 90% of the problem, or 50%, is not about solving this partial differential equation in a good way, which is essential, because if you don't know that part, you get nothing, right? Because it's a problem to solve it. But then you need to add the other 50%, which is the domain expertise. Someone needs to come in and say, okay, what are the materials on the buildings, on the ground? Which directions should we check? What is actually the output? You get a solution, which is a pretty picture, but you have to do some measurements and say, okay, what exactly from this solution is the quantity of interest that you have?
Yeah, no,
and then we need to bring in the domain expertise.
I mean, because I really want to do this. I mean, like, I'm working with Nokia Bell Labs in some way, shape, or form to actually do this. And it's also important for Ukraine to do faster feasibility studies, to faster understand what kind of buildings are there, and what kind of buildings do we need to build, and if that's the case, what kind of buildings do we need to build with what exactly, like concrete, glass, all this kind of stuff, right? So how do I engage?
And to do that, we need to bring in someone who can drive sort of that direction, to create a new curated data set, which is not just a generic simulator, but a generic simulator with on top the domain expertise and the right questions, and package that into some kind of evidence bundle. And that requires, I think, a human that has a drive to work on that for, say, 6 months. That would be okay. I would say the simple answer is, what we need to do that. We need a master student that can work on that for 6 months.
Okay, nice, thanks.
I maybe ask one question, and the answer of you is just one word. I would like to ask you if you have a wish list to our partners here, what should they bring to your project? What would your project benefit the most from? And Franziska, maybe you can start. Microphone, Anders.
Oh, that's a very difficult question.
Could it be data? Could it be the use case that you're currently missing? Could it be someone who's validating your models? Is it someone who can help you running some simulations? What could it be? Access to nature?
It is the question often. So we have a bunch of data, we have very many data layers, and we have partners that are engaging, but we often don't know the real question.
Question, okay.
Yeah, or question / use case and data, but first use case and then data. We have a lot of data, but I mean, can always get more, but we definitely need more use cases.
Yeah, use cases, of course, but also on the data side, what kind of internal data do they have, and how does that compare to the publicly available data? Like we're using, and kind of what does having access to the internal data that, like, the municipalities, for example, have access to? What options what does that open up to us?
More checklists, basically construction site checklists for safety or almost any task, how they're written, how well the reports are written, and things such as that.
So I think I'm more of the use case in this case, because I'm reusing materials that are existing. So maybe like a good platform that have all the data, that I know all these elements, they have these properties, these year where they're made, so I can use these materials in the new construction.
So I would have said a problem, but the question is maybe the nicer way. But sometimes the question is not really clear. But if there's a problem you're working on, and we can see how we ask questions to solve it, then I think the question can be explored together. I think the other thing is it takes some time to work on it. So yeah, often the problems are not answered really quickly. I mean, then you can ask the LLM, what we discussed again. But if it doesn't give you a good answer, then we need more time to explore it together.
Good. Thank you all very much for this presentation, or these presentations. And there you have it. We need some help in various ways, and we're gonna ask you for help after summer. Right. Getting my notes here. We're now continuing with our agenda and with our next keynote. And it's not, the clicker isn't working, it seems. Oh, now it is. And I want to welcome Dessislava. Desi, can you hear us?
Yes, hello. Do you hear me?
Yes, now we hear you. Hello, Desi. Welcome to the DTCC Day, and good to see you again. Desi is, of course, known by many of us because we're friends at the Gate Institute, and DTCC basically started at the same time. And ever since then, we collaborated very, very closely. So we invited you to give a keynote, and I'm very much looking forward to your presentation now, which is titled From Concept to Real World Applications. So it fits right into the more hands-on session of this afternoon. Stage is yours. Welcome, Desi.
Thank you very much. It's a pleasure to join again DTCC Day. So for those who are not familiar about Gate Institute, so can you please give me the control over the presentation? Because I cannot move to the next slide. Okay, I still cannot switch. It works yesterday, but now, no. Okay, it works. So about the Gate Institute, this is the first big data and AI center of excellence in Eastern Europe, and it is founded by Sofia University in collaboration with Chalmers University of Technology and Chalmers Industry Technique. So we start to, as Bernd mentioned, to work together since the beginning of Gate. So I'm going to present our experience with urban digital twins, starting with the concept. You know those concepts, but I will connect how the digital twin works with the digital twin platform architecture itself. So we, of course, need two main components of the digital twin, including data and actions on top of data. A lot of actions was already mentioned, starting with data collection, where we collect data from different sources using satellite images or orthophotos or sensor data, and even generate synthetic data when we miss some data sets. Next, you need to fit the data in the virtual environment using different connectivity protocols, starting with short-range connectivity and wide area connectivity. And here, what is important to decide where to process the data, either at the edge or at the cloud. So before analysis and simulations, of course, we need high-quality data sets, and at this stage, we need to enrich our data sets from various sources, and also to perform different activities related to data cleaning, harmonization, standardization using widely adopted standards and data models. And on the next step, we perform analysis and simulations, relying both on probabilistic models, AI models, and performing physics-based simulations. What is important is to communicate the results with the city stakeholders, and in this direction, we are working on 3D visualizations of the city using web interfaces, applying immersive technologies like virtual reality and augmented reality, and even engaging the citizens with natural language interfaces. And all this knowledge guides decision-making in the city, and of course, those decisions produce actions which generate new data in the city. I will briefly go through the layered architecture that we aim to build, and to connect each layer with AI models that could be applied, starting with data acquisition and data harmonizations, when variety deep learning models can be applied to extract objects or features from images. And then moving to data modeling and semantic integration, where we apply AI reasoning and also rely on ontologies and knowledge graphs for representing the data. Next, analytics and simulation layer comes where you can play with various AI machine learning models depending on the use case, and of course performs physics-based simulations based on computational fluid dynamics, for example, or weather research and forecasting model. Then we have visualization and interaction layer where we apply natural language interfaces now in combination with the 3D city model. I'll give you an example about this later. And on top of these models, we can create different components applicable to different applications, and at this stage, we can rely on agentic AI in order to create agentic systems that can combine different analytical models. And finally, we have, of course, human in the loop in these layered architectures, people who take decisions and that can also validate the outputs of the digital twin. For Sofia digital twin, we have several use cases. So for those who are looking for use cases and for problems, come to Gate. So we start with urban planning and design. And what is new in this direction is that we want to combine geospatial data with legal and regulatory data in order to create RAG system that can support urban planning and produce different urban designs which are compliant with regulations, construction rules, and different environment factors. Then we are working on spatial and temporal air quality analysis, and here, especially for spatial prediction of air quality, we enrich sensor data with geospatial data in order better to predict the air pollution in space. Working also on solar potential analysis of the buildings, and here we collaborate with the colleagues from DTCC, from Chalmers, analyzing not only the rooftops of the buildings, but also the facades of those buildings, and identifying some buildings that lack of solar radiation in cold days during the winter, or some buildings that are too warm in the summer days. Again, with collaboration with colleagues from Chalmers and DTCC, we perform wind and air pollution simulations based on CFD. I will again give an example of this work. We are actively working also on mobility and walkability. In this direction, we apply 15-minute concept, and we analyzed the accessibility of residential buildings to different urban services like schools, kindergartens, shopping centers, hospitals, public transport facilities, etc., in order to calculate the so-called walkability index. And last but not least, we are working on climate simulations with a focus on urban heat island and urban heat risk. So here you can see our visualization map at Gate Institute, where we show the outcomes of analysis and simulations, and we continuously enriching our 3D city model with the data coming from those analysis and simulations. Here you can see the buildings enriched with energy consumption data. Here we generated actually synthetic data for the upper and lower level of consumption for the buildings based on an open data set for 3,000 buildings in Sofia. And this calculation is important to continue with climate simulations, especially with urban heat island. Here you can see how the outcomes of weather research and forecast model, which is a heat map, is integrated with the 3D city building model. And in this case, each building has two additional attributes showing the surface temperature at 4 p.m. and 9 p.m. So here the purple part is the city center, where we have a strong urban heat island, where the temperature is around 6 degrees higher than that in peripheral urban areas. And another example is about the walkability index. As I mentioned, we perform such kind of analysis of Sofia, and here you see that the central part, the green buildings, are very walkable, but southern neighborhoods, which are newly constructed neighborhoods, lack of social and other infrastructure, because of the construction companies focus mainly on constructing residential buildings without thinking for other urban services. And I will go briefly to collaborative work with DTCC and Chalmers on CFD simulations. Here you can see wind simulation in our campus Lozenets, where our new building is located. The red building is Gate building. And similar simulations we performed for Gothenburg area in Sweden. And also with colleagues from Greece, we collaborate on applying CFD simulations on cultural heritage. Here, Militin Castle in Greece is shown, where we simulated the wind pressure on the facade of the castle and wind flow. And another interesting project that we had is wind tunnel testing experiment, which is done in University of Eindhoven. Here you can see how the 3D model looks in the wind tunnel. Again, the study area is part of Sofia city, the central part, where we selected several tall buildings surrounded by a lot of low-rise buildings. And based on this testing, now we have open validation data set of wind velocity and pollutant concentration. And we also prepared best practices validation protocol for urban CFD model. And of course, this support implementation of the Sofia digital twin. So the experimental data set is openly available, and it is a valuable asset for validation of CFD simulations. Here you can see how the simulation looks like in a real engine. As I already mentioned, we need appropriate way to communicate the outcomes of our research. And here the wind simulation is presented with a heat map in the 3D city model, and the end user can play with different colors to change the view of the camera, and even to select the type of visualization, for example, to use some particles to visualize the wind flow, and to change the size of those particles in order to have better experience. Another interesting scenario is related to our building, where we use actually Gate building to create digital twin at building level. So our building is equipped with 67 sensors. So we are measuring energy consumption in different circuits. Also, we collect data about CO2 and temperature, and we have very detailed actually 3D model of the building where you can explore different building construction elements. So historical data also can be is integrated in this 3D city model, and we are working on integration of predictions of energy consumption Here you can see how the temperature is visualized. Each cube corresponds to a separate room in the building. And similar visualization we have for the CO2. And about LLMs, generative AI, and natural language interfaces, here you can see our chatbot, which is integrated again in the 3D city model, and you can ask about the past air pollution, and the chatbot plays actually 24 animation for the pollution. You can also ask the chatbot to navigate to different places, and what we are working on is to integrate also the outcomes from analysis and simulations, and to allow users to ask questions about those analysis and simulations. And now I will go back to the digital twin, and in the heart of the digital twin is data, and in this direction GATE is very active in international data space community. And we initiated the first urban data space in Bulgaria. So what about the data spaces actually? It is not a centralized data storage, but ecosystem of stakeholders that are willing to share data in order to create new services and new business opportunities. Of course, data spaces rely on standards and different interoperability mechanisms. They are also supported of data governance mechanisms, and now we have even a project for compliance of the data spaces with regulations, including Data Act, Data Governance Act, and AI Act. And how data spaces are governed from rules for access and use of the data. And the data spaces has several values, not only economic impact, because they create new services, new products based on shared and reused data, but also they have an ecological impact because they enable resource optimization, also allow performing sustainability analysis and simulations. And finally, they have social impact because they connect communities and they allow new services to be produced for us, for the citizens. In data space direction, we have one project which is pilot implemented within European data space for smart communities. So our pilot is dedicated to positive energy districts, and we have two cities in the pilot, Sofia municipality and Rubi municipality in Spain. So what we aim to achieve is to collect as much as possible data in order to explore the sustainability regarding the energy and to perform energy flexibility analysis. Here you can see how the data space looks like. So from one side we have data providers which put so-called data offers in the data space, and then we have data consumers from the other side, which can browse the data space catalog in order to explore the data sets, and then they can initiate negotiating process with the data providers for access of the data. And after agreement is contracted, the actual access of the data is point to point outside of the data space. Additional role is available for service providers who can offer services on top of shared data. And in this pivot, we use this data in order to facilitate the implementation of our use cases of the digital twin. And another project related to data spaces is called European Mobility Data Space. 9 cities participate in this project, including again Sofia municipality. So GIT is coordinator of the local deployment of the data space, where we collaborate also with Sofia Urban Mobility Centre. And we have 2 use cases in this project. One we called green mobility, where we want to combine public transport data with micro-mobility services such as shared scooters, electric cars, also bicycles, in order to provide new mobility as a service for the citizens. And our second use case is related to navigation of the people in urban environment, related to walkability, where we want to combine parking data with built infrastructure data and other data sets related to the quality of urban environment. So what we want to achieve here is to stimulate the people to park nearby and to start walking from point A to point B. And navigation here is performed not considering the shortest path, but the most pleasant path for the end user. For example, we are considering shadowing the pavement and other factors, and either allow end user to report the quality of the urban environment through the app. And this brings me to the end of my presentation. So what we want to achieve at the end is to create urban digital twin powered by human-centric artificial intelligence. And this urban digital twin will adapt, continuously learns by itself, will think, make strategic decisions, and will talk, chats with people in a natural language like a human. So thank you for your attention, and I'm open for questions.
Thank you. Thank you, Desi. Yeah, I'll forward that question directly to our audience. Are there questions for Desi? Everybody is starting to get a little bit exhausted after.
Probably, yes.
I would have a question.
Thomas is not.
No.
Go ahead, Thomas.
Yes, thank you very much, Desi, for the great presentation. I have especially a question regarding the data spaces, because I know that in the Data Spaces Association, there's pretty much promotion of the ontology and the data model that they are promoting there. Does that mean everything that has to go into the data space has to be converted or transformed into that representation? And later on, if somebody wants to consume the data, maybe it has to be retranslated? Or does in this data space, the data lives in the original representations?
No, it is not obligated the data to follow a specific data model or to rely on ontologies, because ontologies are, how to say, you can use various data models and ontologies actually, and that is why there are service providers in the data space, so they can provide different services for the data providers if they want to transform the data in a different format or to be compliant with some ontology. It can be done through these services. And of course, data consumer can also ask service provider in order to transform the data regarding some ontology or some data model, but it is not obligated. What is
Important is to put as much as possible metadata about the data you offer in order to the data to be easily findable in the data space. But currently there is no, how to say, standardized way for the data space components.
Yeah. Do you bring OGC services, OGC compliant web services directly into this ecosystem, and just have this additional facade, or how are you dealing with this?
It depends on the implementation of the data sets, the data space components actually. So there is no some connection with for our data space with OGC. We rely, for example, on Eclipse data space components, which are open source. But you can extend the data space components, for example, to put new functionality to connector component, which can perform some additional activities.
Okay, thank you.
So what International Data Space publishes this data space protocol. So you can follow the protocol, but the implementation can be different. For example, Fireware Foundation provides data space components also, and yeah, still not single solution.
Do we have more questions online, it seems? I see. Aha, Nicholas is also... No. Nicholas, if you can hear us, is there a question? No? Ah, he's coming in. Take the microphone.
Yeah, hello. Hey, this is super interesting presentation. I just had a question because I worked with smart buildings before about the building twin. Twofold. One is, do you do any actuation as well? Or is it more simulations and analysis?
Only simulation and analysis. This is future work. And as one of my colleagues also joking, he wants such kind of actuators in order to avoid sun in the room. So yeah,
exactly.
Currently we don't have.
And for the, can you zoom into the room and see where the sensor is? Because that's usually the problem, that the sensors measures the room, and then you think that that temperature is in the room, but it all depends on where the sensor is located.
Yeah, only the whites are automatically controlled.
No, not from an automation.
Yeah.
No, not from an automation perspective. As in, can you zoom into the building twin and see where the sensor is actually placed in the room?
Yes, they're integrated in the 3D model, actually. Yeah.
Okay. Yeah, because that's usually one of the biggest problems, that you think it's warm or cold, but it just depends on where you're measuring. Then the second question is more, does anyone actually use this to make any decisions and to optimize decisions today from the municipality?
Some analysis, yes, but it's very difficult, because now Sofia municipality actually struggle with digitalization of data. They start to work on building data platform first in order to collect the data from different departments and different city stakeholders. Then we can put our analysis on top of this data platform, because some of our analysis, for example, are based on not fresh data, for example. And we need, for example, for the heat island energy data, but the energy provider don't want to share data. And this is some kind of problem. And then this is the role of municipality to, to collect the data from all stakeholders in the city, because they operate on the territory of municipality. But the good news are that we have new mayor of digitalization, and he comes from industry, working from big software companies, so he knows what to do, actually.
Okay, thanks.
Good. All right, then thank you very much, Desi. Big round of applause for Desi.
Thank you.
Yes, time for our final keynote of today. And now we're getting back to Sweden and to Anton Gustafsson, bringing a little bit more, I would assume, a strong applied research perspective to this discussion. So please welcome Anton Gustafsson at the RISE Research Institute of Sweden.
Thank you, and also give me the thumbs up if you can hear me. Yeah. So this presentation is something I put together based on a number of frustrations. One of them being all these buzzwords with data spaces and digital twins and cityverses and so on, and some kind of ambition to try to understand these kind of terms instead from the perspective of their abilities. And also, like when we work with municipalities, we often get the question, where do we start? And how far do you think we have gotten? And things like that. So we tried to do some kind of digging into this. But before I go into that, I will talk a little about the approach that we usually have when we interact with a municipality. First of all, we kind of deliberately stay away from the buzzwords and focus on this specific thing. How do they today do the collaboration in the city, and how can they improve the data-driven collaboration when decisions are informed by relevant data and so on. And usually we start with assessing the current situation. We then have a couple of workshops where we try to figure out what are their needs. And in parallel with that, we also look into all this exciting new technology that is basically coming every week nowadays, and how it fits to those needs. But then we also have this kind of mindset that in order to understand something, you got to build it. So we try to combine these ones into prototypes, and sometimes these prototypes are just mere screenshots, and sometimes it's more of a working prototype. But there's a learning story there. So these kind of prototypes then, of course, can help us reevaluate the current situation, reevaluate the needs, and understand more about the data and technology and so on. So let's just look on the questions that we ask during a normal workshop. In a normal workshop, we can gather, for example, different parts of a municipality or a city, different divisions, or we could gather building companies or other and have them talk to each other. And then we ask them the question, who needs to collaborate? What do they need to collaborate about? What kind of data supports this collaboration? And then we get into the digital twin stuff, and that's like what objects and properties needs to be represented in the digital twin for this specific collaboration. So here you can think of it as a game board, and those objects are the pieces on the game board. And the last question is like, how do we interact around these objects with each other? And that's basically how do we play the game if we're using the metaphor. So a typical workshop, we have tons of different needs generated, like why do we only see our own perspective? How can we get a larger situational awareness? A lot about optimization, which elevator do we check first? How do we know when we should empty the trash bins, and how do we share data? Data is shared by USB sticks once per year between some divisions in the municipality, and you never have the same or complete vision of what's going on in an area in terms of the data. Also attractiveness and inclusiveness in the city and safety, like these reports, security reports that come in and the measures that they do based on them. How do they actually perform? Are they doing the right stuff and so on? And of course, there's an endless flow of these kind of collaborations in the city. It never stops. Every week we find new ones, and of course, if we're going to be making one application for each of these collaborations, we're in trouble, because there will be a lot of them. And in Eskilstuna, for example, they made this application to make them not having to dig up the same street 3 times each week from different departments, but it only took a year or so, and then there were new people coming into the organization and they didn't know about these applications. Of course, the same problems started to appear again. But if we look on this specific case from Botkyrka that we explored a couple of weeks ago, there's a person responsible for the reports that citizens file. In this case, it was about the tree that was about to maybe damage a fiber optic line. And then they need to investigate and figure out who is responsible for taking down this tree. And for this, she was using actually several apps, one for looking up the address, one for looking which one was responsible for it, and then Google Street View just to be able to figure out which tree it was, which direction the person had taken the photo. And then there's one system for registering all those incoming kind of files from citizens, and then there's another one for sending the order to the entrepreneur who's going to cut down the tree and so on. Yeah, so this is basically how it looks today then. So what is needed from a technical perspective to support a data-driven collaboration in the city? So here we try then to reformulate these buzzwords into abilities. So the ability to find data in the city, the ability to access data in the city, and the ability to connect and link data in the city, as well as to interact around the data, and also finally to give data its own intent. So if we start with the first one, then it's kind of simple. We need to know what kind of data that is available there, and also potential future data that we can actually collect. And this directly connects to this question that we have in the workshops: what kind of data supports the collaboration? And it's sometimes very hard for them to answer this question, and there's a lot of research needed to actually to come to a conclusion regarding a specific problem they have. But as you all know, there are these data portals. This is the one from Stockholm City, and as all of the other data portals, it's pretty much sucks. It's not all the parts of the city is actually filing their data here, so there's like a partial coverage. Also, I think they deployed it. They started working on it in 2014. It's not until now that it's actually been started to be more widely used inside the Stockholm City. Also, it does only contain the data that the city provide themselves. But in this case, where people inside the city needs to create new work models for collaboration, they also would like to know the data which is not the data provided by the city. So these kind of portals should also make it available for them to search for other types of data which could be useful for them. And then if I enter Kista, which is a part of Stockholm, into this, I get 0 hits. And there's actually a lot of data about Kista here, but we only have metadata on like a data set level, not on the objects in the data sets. So that's a problem. We can actually search for city parts, and then we get a zip file which we can download. We can extract it, we can open it in QGIS, and then in QGIS we can find Kista, and then we can find some properties of Kista, like the size of it. So we've been exploring now using AI, and then there's like this before case and this during use. So one is like having the AI go through all the data sets and try to make sensible tags, and also doing this indexing. So if something contains an object called Kista, and another one contains an object called Kista, trying to match them together and so on. And then during the use, then when you search for something, the AI can actually help you set the filtering, and it can also go through the top results and actually order them in so they actually match better your query and so on. So the next step is, of course, with the previous step, you might be well aware of that there's a lot of work going on in EU, among other places, around these data portals. On level 2, we're more coming into the area of data spaces. So accessing data in the city is not always a pleasant experience. In many project we have, it's not until the end of the project you actually get the data, and sometimes they actually have to share the login to an external kind of data supplier for you. So there's all this kind of problems around this. And Anders was saying that AI is solving the integration problem, but situational awareness requires multiple data sources for each app. So each app needs to connect to quite a large number of data sources. And as the apps and the data sources increases, it becomes quite a large problem. So there is a need for some kind of middle layer. And also if you have the middle layer, of course, the people having the APIs will be more keen on changing the APIs and making sure that middle layer knows how to read their data and so on. So that's level 2. Level 3 is when we are getting into the more interesting stuff, and this is the digital twin level for me. And it's digital twin for me is very much about connecting data. Digital twins, I would argue, are object-oriented, not system-oriented. And even since we started doing those cave paintings, we have tried to kind of make a copy or describe the world, and we're still doing it, but we're doing it in the silos with different data formats on different servers and so on. So we're not kind of sketching on the same sketch, everyone. We're keeping to ourselves and describing the world. So this is of course problematic. I mean, if you look on the current project we have at Botkyrka, they have several different systems for service errands or citizens dialogue when the citizens have some ideas for improvements. They have some internal reporting system, and if you want to know what's going on a place, you need everything collected in one place. Also, if just having a tree, there's a database that the city, the street office of the city might have. There's this aerial photography that you can see how much the tree has been growing. And if you have a web camera, you can see if it's shedding its leaf during the autumn. At the same time, maybe you have a sensor on it or something like that. All that needs to be put together in the digital twin. And also, this is a problem we see a lot with sustainability issues. If they try to fix a problem, they usually end up creating 3 more or 4 more other problems. So in one project, they wanted to lower the temperature of the building during the night when no one was there, because that saves energy. There's not nearly enough, or there's less heat escaping through the walls when there's less heat difference. But then in another project, actually with Gothenburg Energy, they wanted to actually raise the temperature during the night and use the buildings as energy storage, because in the morning, of course, a lot of people want to take a shower and use heating. So then they have to put on an additional boiler, which is usually not a fossil-free one. So if you have the system perspective, you might actually cause more damage with your measures that you're trying to save energy. So, I mean, also the power of combining things visually. I mean, sure some of you have seen this before, but it's just combining the temperature reading down there and having them synchronize to the video. It synchronizes with the temperature reading, and then I can understand how to cook my porridge without burning it and so on. So the idea we had in one of our projects was to create this amazing 5-dimensional real-time graph of the city. 5-dimensional is that some parts of this connection only exist after a certain date, and some of them only exist in a certain scenario. So we have both the dimension of time and the dimension of different future scenarios. And the idea here is if we have a camera, we know where the camera frustrum hits the road. We know that the road is connected to an intersection, to another road, to a garage, and we have some energy monitoring of that office. We can understand that, well, there should be a collaboration between this traffic in this camera and this energy usage in the office. So basically, if we are going to build here and there will be parking lots lost, and there might be some shadows on the solar panels on the building next to it, there might be more water problems, there might be a problem with getting through here as more people start to work here. Then we can give this particular building its own timeline where all these kind of events that are relevant can occur. So this is from one prototyping session we had when we looked into how you would view one of these 5-dimensional digital twins, and of course we can see future buildings at different planning stages, and we could see that the camera images was synchronizing with the timeline. We can also see then how we can select different scenarios and so on. So in order to create this interconnection of data, we need a shared address space. So today we can usually address a certain data set. So we just put in the server name and the data set name maybe in our browser, and all of a sudden we're there and we can view the data set. But we also need to be able to actually address objects within that data set and also properties on those objects. So that would be a next step. And the further step would be that we can have a protocol that supports real-time communication so that we can subscribe to this property, and whenever it changes, we know that it has changed. We get an update immediately. And also that we can address historical data so we can see what this property actually was a time ago. And this is another prototyping session. So here you can see I clicked myself, and you can see how my age is changing when I pull the timeline forth and back. And then we can see the number of employees at Ericsson, for example, and see how that changes over time. And then I click my colleague eventually here as well. And yeah. So here is, if we click this property and then press Ctrl+C, we actually save the link to that property. And what that does for us is that we can then move into Excel. We can paste that. We have a small plugin in Excel, so we can paste that URL, and then all of a sudden we can have the age of my colleague inside Excel then. So we can actually access the same data on different places, but it's just one data set, and it updates in real time. So in this case, we can see like when we have these future buildings here, if we copy the link to them, I will speed up this a little bit, and then we go into Blender, and then we paste the same link. We have a plugin in Blender that actually loads it, and if we change it and we save it, it will actually update then immediately in the digital twin. Let's see. Yeah, so like that. And also, of course, we support different web applications where we can see the same geometry, and whenever it changes, someone goes into Blender and changes it in the digital twin, it will update them on every places that are available. So also thinking of it, like most of the things in a city is about connecting things. You know, when they do building permits, they look on the different laws that are applicable to this case, and they look at the plan for the area, and they look on the description that people has written about what they want to do. But also it's like in this case, most of the connections are made in people's heads. It's not it doesn't reach this kind of digital realm, and that's problematic because a lot of it can be reused for the next building permit or things like that. But today, of course, we see a changing landscape where we can actually have a BIM blueprint where we can get knowledge of this share. We can have a web camera where we can see if the share is used. We can have the invoice and see how long is the warranty on this share and stuff like that. Ericsson has in one of our projects been monitoring their parking lots, and they've been having a beehive on their rooftop and monitoring the bees as well. So the bees are kind of like a sensor on how the biological life around it is. So if people have a lot of clean-cut lawns, for example, they will starve during certain periods of the year, and if people have more like wild grass growing, they will have food continuously and so on. So also it's like trying to figure out where this camera matches objects in the model with its pixels and stuff like that. So I mean here, if we look at this, we have the aerial photography. We get a new one maybe once per year or every second year. We have the satellite photos 2 times per week, and then we have put up this camera on Kista Science Tower. But even if you have it as a stationary camera, it will be moving a little bit. So you need to track that with AI, find feature points and stuff like that. And then if you find that there's been solar cells installed here with the aerial photography, you can actually see it, but you don't know exactly when it was made. It's like somewhere between these 2 years. But then if you look on the satellite photo and match it to those specific pixels, even though if you can't see it, you can actually make out when they were actually installed from the changes of those pixels. In this, we're trying Gaussian splatting a lot. Gaussian splatting, as some of you might be aware, is you use AI to generate basically brush strokes instead of 3D models. So it captures these kind of trees much better, small things like lampposts and stuff like that. And here, this is actually Stockholm City that has been also looking at the SAM model, segment anything, to actually see how it can segment those kind of brush strokes in the Gaussian splatting. And this, of course, creates a lot of opportunities for then asking AI how many windows are facing this particular street and things like that. So yeah, connecting data. So level 4 then, here is, so if level 3 was the digital twin level, then we have level 4 is the cityverse level. And cityverse for me is basically if you're using Mural and you can see your colleagues running around there, or if you're using Google Drive and you can see the cursor of your colleagues writing something next to your text, that's basically a cityverse for me. It's the ability to see each other in the kind of data that we have. And yeah, so this was just some prototyping session we had. So my physical location here is at this office, and then my colleague, which is actually sitting in Eskilstuna, is virtually visiting Kista here and our office. So we have this kind of 2 kind of locations, and instead of just monitoring the traffic on the road outside, we also need to monitor the digital traffic, because we can of course make heat maps of this and then understand that, well, I have a colleague which are very interested in this intersection or this part of Kista, so maybe I should give him a call and ask what kind of project they're doing there, because I'm also doing a project there, and things like that. And of course, if you think about it, it's not that new. If you work as a police, you can go into the registers and look for people, but you can't do it at your own whim. You have to have like some suspicion or something. You can't go and check your neighbors, and if you do, you're getting logged, so people know where you've been digitally and so on. So it's not something new in that regard. Also, like we put in chat functions, so all the objects in the digital twin has a chat window, so you can talk about that object with your colleagues. But then when we started using that, we kind of started thinking, why shouldn't we have an AI bot in this chat as well? So instead of addressing my colleague, I can address that AI bot and start asking questions. And there's a lot of PDFs with where they do investigations about this planned proposal. So then I can get the AI bot to give me some information about this. And once we were at it, we tried to have this AI bot actually posting news that is found on the web regarding Kista. And there was one news here, which it's labeled as positive news, that KTH was moving, and they had the last time they had their kind of festival. But of course, that wasn't a correct assessment, because KTH moving was kind of actually a really sad thing for the people in Kista. and now Ericsson is also moving here. So it's a big problems here in Kista regarding this kind of things right now. Also, like it's always fun to play when you start getting these MCPs there. You start to look what can it do and what can it not do, and in this case we just asked it to change the time to the king's birthday the year after. But a more serious kind of thing would be if we look on those traffic camera images that are coming in, we can see that, well, we're using this system with real-time kind of chat rooms. So the traffic camera has its own chat room. It's connected to a storage unit, so we can see historical images, but also we have this client where we're viewing it, and we have a computer vision algorithm that goes in and actually counts the number of cars in each picture, and then it will actually listen to the real-time images from the camera as well. So it goes through the historical ones and then listen to the camera if there's new ones coming. And then, of course, if there's a new picture coming, all the subscribers get notified of that picture, and they can show it if it's the client, and they can store it if it's storage, and the computer vision algorithm can process it and count the cars. And then the result is also stored. And if I ask ChatGPT through the client of when was the most traffic in February on this site, in this camera, it actually can go to the storage and it can find it, and then it sends the result in the chat and also the command to change the view to that particular point in time of the timeline. And then I can see for myself that, yeah, it was quite a lot of traffic here during this particular time. So that's a little bit how things would be functioning under the hood as we see it. And then we have the fifth level then, where some of these people which have both their virtual location and their actual location get replaced by some kind of AI agent. And that AI agent would then be given a mission and maybe start bothering people when it thinks that something is wrong. But these kind of things, I think, build a lot on that we have this kind of structure underneath. And also it's like in any municipalities, no way of getting away from the systems that we already have today. So this is one scenario. If a person is interested in something, maybe wants to know something about Kista, we can connect to the broker, and then we will be connecting to the existing data portal and ask about Kista, and then we get the answer that, well, in the GIS system there is some information about Kista that you can check out with this link, and we use that link in the broker, and the broker sends us to the GIS system, and we can see how big Kista is, for example. And then we are also interested in what kind of things are there in Kista, and then we are connected to the knowledge graph server. And we use the link that we had to the GIS system and ask the knowledge graph what kind of other objects are related to this address field. We will then get back that, well, there are some streets, there are some cameras, there's some solar panels as well. And the solar panels are in the IoT system. So then we can use that address to the solar panels, connect to the IoT system, and get some information about how much the solar cells have been producing in Kista. We can summarize that, and we can divide it by the size of Kista, and we can compare it to another part of the city, for example. But then also it's like we might be interested in, is there anyone else that has been looking into the solar panels in Kista? And we take the addresses from the IoT system that points toward the solar panels, and we put it into the Cityverse server. And the Cityverse server will tell us that, well, you have a colleague on another department that actually have been doing a lot of work and getting this data. And then we can connect to our colleague and ask what they're working with. So this will repeat basically, but we will have these kind of bots instead that do these kind of traversing of the kind of knowledge graphs and figuring things out. And as you might know, now there's been some kind of mixed results of this. Typically today, I mean, there is this kind of agents that work continuously, and they usually have these kind of organ. So they have a heart, which is basically a clock that wakes it up every second hour or something like that. Then it starts by fetching this file, which is its soul, which has a kind of mission statement, what it should do. And then after that, it collects the tasks, which are what it was up to last time it was running and stuff like that. And then, of course, it has its toolbox where it can, traverse those kind of knowledge graphs, fetch data, and bother people through emails or other means. So there is an example of this where this bot was giving the task of getting some code base into an open source repository. It started doing that, but the code was rejected by the repository owner, and then the bot started instead a smear campaign towards the repository owner in order to force him to resign. So there's still some problematics around these kind of AI agents, obviously. But there you have it. Here is the 5 steps converted from buzzwords into abilities. And that was all I was going to talk about today. Any questions?
Thank you, Anders. Yes, are there questions for Anton? There's one here in the room. 1 second.
So thanks, Anton, for a great talk. So very interesting and very many different prototypes and use cases. So are you trying to at all build some kind of libraries, reusable components? I mean, you build a lot of prototypes. Is it like throwaway prototypes, or do you have some ambition to build frameworks, libraries, things that can be reused, or are you already doing that?
Yeah, I mean, I think like always, there's the ambition there to make something that could actually make a difference and stick around for a while. But then you have the budget restraints as well. So most of it becomes one of those, as you were expressing it, throwaway prototypes. But we are working on some of the open source releases as well. Most of the stuff is available there, but it's just not that well documented. So if anyone wants to get into it, they will probably get a headache. But we wrote a couple of articles on the DigiWiz page about it as well. And we will, of course, continue working on it. But it's also like all the time you also want to redo your design basically also. So you start thinking of a better way to solve a problem, and then also the old stuff becomes obsolete quite rapidly.
Great, thanks.
Maybe I have a comment. Thank you very much for the nice and not just for the nice, for the great presentation, especially also the prototypes. What I found very fascinating was the consequent use of publish and subscribe patterns in your framework. Maybe that's just a comment from my side. When it comes to 3D city models, there is a mechanism now that we have in CityGML version 3, which is called Dynamizer, which allows you to explicitly tell that one specific property of any city object is, however, being served dynamically by a sensor. And you can use, for example, also MQTT as a protocol, and you can basically name that. So that would be a possibility to bring and I would say to represent this possibility that things have some dynamic aspects in a persistent way.
Yeah, I mean, the idea was inspired a little bit by the work that RISE did in its earlier days when part of it was called 6. They wanted to, there was a lot of protocols popping up for home automation, for example.
Yes.
And there was developers were having a huge headache because they had to handle several different protocols. So people working at 6, they started to construct the world's smallest IP stack, so that you could be talking IP with whatever device you wanted. So you could actually start to have IP communication with satellites and all that kind of stuff. So that simplifies stuff quite a lot. And we were also frustrated. We were doing a lot of energy service projects before, and we had, you know, one protocol for getting the historical data, one protocol for getting the real-time data, and then we have to sync and see that we didn't miss anything in between those and stuff like that. And it was just giving us a headache. So in this, when we started with this digital twin thing, we just decided, like, why not use the least common denominator, which is like, even if it's not the sensor, it could still be real time. And it paid off quite well. And now it's like we have this project in Gothenburg, for example, where at Liseberg and Svenska Mässan, we're counting the number of cars arriving with deliverance, and they kind of run them through some kind of middle station where everything is loaded together to make the traffic to them less and so on. But then if I have a stream processor that processes the data coming in, and we made something error in that stream processor, or they want another attribute added to it, we can just update it and then rerun the whole history. And if you're viewing it, you will see the data changing historically all the way back to now when the process is working. So even historical data needs to be treated as real-time data. I think that could be changed at any moment, so sort of. And it made our life much more easier. Then you have other problems, like if you divide everything into small pieces and subscribe to them, you will get a lot of overhead. So you need to find ways of caching stuff. Maybe, you know, you can get a big zip file with all the cache data, and then you can start subscribing. And if there's no updates since the zip files data and so on, there's no data sent and so on. So there's a lot of those kind of issues to solve behind the scenes.
Thank you.
I can ask here. Okay. I have some kind of open question for you. I just want to know your perspective on the security regarding these like levels. It seems like the workflow is like great, but I think like it's my hunch, if we have put security into the perspective, there will be like a lot of problems. So I just like want few words regarding security.
Yeah, I mean, prototyping, you usually disregard some aspects, and one of them might be security, that you try to do something quick and dirty. So I might not be the right guy to answer, but still, it's like when it comes to, for example, level 2, be able to access data in the city. I mean, the worst thing you can have is security by obscurity. So the security basically is that it's so hard to get to the data, so you can't get it. So today there's a lot of security issues. Like when we were working with Nacka, for example, they basically gave us their own login for external services for monitoring bicycle traffic and stuff like that. So once we leave the project, we still have access to their data. So if you have a proper system for handling data access, I think it will improve quite a lot of things. Also, it's like when you visualize things in a digital twin, you have a lot of benefits of seeing that people might have data that they shouldn't have, or I mean, one thing with maps is also you can see what you don't have, and if you have two, for example, when we're collecting the cars for Svenska Mässan, there's both a magnetic sensor and there's a camera which is counting or actually reading the number plate. And of course we can compare those both data sets. If you're running it and you see, oh, I get a trigger on the magnetic data but not on the registration plate reader, then of course you know that there's something wrong with the data. There's more cars running into Svenska Mässan than going out from Svenska Mässan. So either they have a big pile of cars in their basement or there's something wrong with the server. So I mean, some things are really helped by these kind of systems, I think. And also when it comes to the cityverse, the case in Botkyrka, she needed to assign the task to the right manager. So was it the forest manager, or was it the street manager, or which manager was it? And she had this GIS map, but sometimes the GIS map was wrong. And if she could immediately just make a kind of a chat message on the GIS layer and say like, well, this needs to be redefined because this is wrong, you know, and that message then reads the right person. It's easier for the organization to keep the data up to date. Might still be someone that needs to verify that it should actually be changed and stuff like that. But I think those kind of communication could improve a lot. Then on the other side, one of the most scary things in security is the kind of social engineering thing, you know, when you actually phone people and get them to give you data without hesitation and so on. So that could be, of course, a problem if you are able to interact like this around every data in the digital twin.
Thanks.
Thank you, Anton. I think there are no more questions now. So I want to thank you, Anton, but I also want to thank everybody, all the speakers that contributed here with some incredible talks. So let's give us all a round of applause. So we're coming to an end now of the official part. I think it's not easy to summarize this now very quickly. So on a very high level, of course, it becomes very clear that our digital twin landscape is changing, and that we're gonna AI, no matter what, will play a role in the development and maintenance and running of digital twins. And we need to ask different questions. We'll get different answers, and I really look forward to the next few years now in DTCC, because it seems like we're in many ways on the right track. Looking at the projects. Producing very soon tangible and good results. So it will be very interesting now to also engage you as partners in those projects and in DTCC even more. Thank you very much for coming. There is fika now outside, and then continue with conversations, I would say. Thanks, everybody.